In 1976, NASA's Viking 1 spacecraft took a picture that amazed the world. On the surface of Mars, in the Cydonia region, a huge face appeared to stare back, carved into the red planet itself. At first, NASA said it was just a trick of light, but over the years, clearer images showed not only the face, but also nearby shapes that looked like pyramids, walls, and even what seemed like a whole city hidden under the Martian dust. What did NASA really discover in Cydonia? Could Mars have once been more than a lifeless rock? Could it have been home to a powerful, godlike species that later came to Earth? Before we begin, let us know in the comments below where in the world you're watching from and what time it is there now. Now get ready as we uncover what NASA found in the hidden Cydonia region on Mars. On the 25th day of July in the year 1976, NASA's Viking Orbiter 1, part of the ambitious Viking program tasked with exploring Mars, captured a remarkable series of images over a region known as Cydonia, located on the northern plains of the Red Planet. Among these images, one photograph immediately captured the imagination of the world. It appeared to show, with uncanny precision, what looked remarkably like a human face, staring upward from the Martian surface. The face stretched over 1.5 miles in length and seemed to possess distinct features that resembled eyes, a nose, and a mouth. The sheer size and familiar contours instantly provoked curiosity, fascination, and naturally debate. Was this a quirk of nature, a trick of light and shadow, or something far more extraordinary? An artifact of intelligence from a time long before humanity had walked the Earth. But before we go deeper into the mystery of Mars, I want to thank today's sponsor, Manta Sleep. Working late nights on space documentaries means my schedule is often upside down, and good rest is the one thing that keeps me sharp. That's why I use Manta Sleep. Their masks are designed with absolute precision to block out 100% of light, giving you blackout-level sleep whenever and wherever you need it. The material is soft and breathable, and the fit is completely adjustable, so it feels comfortable whether I'm taking a short nap in the middle of the day or getting a full night's rest. Manta Sleep is also all about the pronap movement, redefining rest as something to be proud of, not guilty about. And honestly, I couldn't agree more. Rest is fuel, and with the right fuel, I can keep exploring stories from the edge of the universe. And here's the best part. You can try it for yourself today. Just visit mantasleep.com and use my code Spacedust at checkout to get 10% off your order. So whether you want a quick recharge during the day or deep, uninterrupted rest through the night, check out Manta Sleep by clicking the link in the description below. Now, why is the Cydonia finding on Mars so important? To understand the significance of this discovery, it is important to examine the context of how Cydonia was first documented. The Viking missions, Viking 1 and Viking 2, were pioneering spacecraft that provided humanity with its first detailed views of Mars's surface from orbit. Together, they captured a total of 18 images of the Cydonia region, each varying in clarity and usefulness. Out of these 18 images, 7 possessed resolutions finer than 250 meters per pixel, providing relatively sharp and detailed views of the terrain. The remaining 11 images were much less clear, with resolutions worse than 550 megapixels per pixel, making them largely unsuitable for detailed study of surface features. Within the 7 high-resolution images, however, the timing and lighting of 2 sets were so similar that only 5 could be considered truly distinct observations. It was during one of these observations, specifically an image captured by Viking 1 on the 25th of July 1976, that the now famous humanoid appearance was recorded. The feature, later dubbed the Cydonian Mesa, measured approximately 2 kilometers in length, equivalent to 1 2/10 miles, and was located at 40.75 degrees north latitude and 9.46 degrees west longitude. At first glance, the mesa bore the unmistakable semblance of a human face, complete with eyes, nose, and a mouth, carved not by human hands but seemingly etched into the Martian landscape itself. Despite the excitement this inspired among the public, the chief scientist for the Viking program, Gerald Soffen, initially dismissed the striking resemblance as nothing more than an illusion, created by the interplay of sunlight and shadows, a clever trick of light that fooled the eye. Yet, the story did not end there. A second image, catalogued as frame 70-013, captured the same face from a different angle, 35 orbits of Viking later, with the sun casting its light differently across the terrain. This discovery was made independently by two computer engineers, Vincent DiPietro and Gregory Molinar, who were working at NASA's Goddard Space Flight Center. While examining archived NASA images, they uncovered the two misfiled frames, Viking 035A72 and 70-0A13, revealing the face from two distinct perspectives. These images had resolutions of approximately 50 megapixels per pixel, far finer than many of the other images from that era, providing a clearer view of the enigmatic feature. For over 2 decades after the Viking images were taken, Cydonia remained a subject of speculation and intrigue. During this period, several spacecraft visited Mars, bringing with them more sophisticated imaging technology and providing new insights into the region. NASA's Mars Global Surveyor, which orbited the planet from 1997 to 2006, and the Mars Reconnaissance Orbiter, which began operations in 2006, captured much more detailed images of the Martian surface. The European Space Agency also contributed to this endeavour with its Mars Express probe, operational from 2003 to the present day. In contrast to the relatively coarse resolution of the original Viking photographs, these modern instruments offered unprecedented clarity. For instance, images from the Mars Express probe achieved resolutions of 14 meters per pixel or finer, allowing scientists to study the terrain in remarkable detail. By combining the data from the high-resolution stereo camera aboard Mars Express and the Mars Orbiter camera on NASA's Global Surveyor, researchers were able to construct a three-dimensional representation of the so-called Martian face. From these analyses, scientists determined that the feature was a natural Martian hill. Its facial appearance, they concluded, was a classic example of a psychological phenomenon known as pareidolia, the human tendency to perceive familiar patterns, such as faces, in random or ambiguous visual information. NASA's subsequent statements reinforced this interpretation, emphasizing that the hill's face-like qualities were dependent on the viewing angle and the way sunlight illuminated the terrain. In essence, what had seemed like a deliberate design was nothing more than nature's playful shaping of rock and shadow. However, not everyone accepted this conclusion. Among the most vocal defenders of the idea that the face on Mars was an artificial construct was Richard Charles Hoagland, born on April 25, 1945. Hoagland, an American author and former science advisor for CBS News, became a prominent advocate for a range of alternative theories concerning NASA, lost civilizations, and extraterrestrial life. He argued that NASA was deliberately concealing evidence of advanced life on Mars, citing a report commissioned in 1960 by the Brookings Institution. According to Hoagland, the so-called Brookings Report, specifically page 216, recommended that NASA withhold from the public any discoveries of extraterrestrial activity on the Moon, Mars or Venus, to avoid social disruption. Hoagland used this report to support his theory of a NASA cover-up, suggesting that the organization had long hidden the truth about structures on Mars that indicated the presence of a once-thriving civilization. Hoagland further expanded his theories with the proposal of what he called hyperdimensional physics, which he claimed was a more complete version of James Clerk Maxwell's original 20 equations, as opposed to the commonly taught Maxwell's equations revised by Oliver Heaviside. In Hoagland's view, the face on Mars was merely the most prominent feature of a larger Cydonian city, a settlement featuring colossal pyramids, mounds, and other structures arranged with deliberate geometric precision. According to him, these formations were remnants of an advanced civilization that had flourished on Mars long before humanity appeared on Earth. Hoagland detailed his ideas in the book Dark Mission, which argued that NASA had knowingly, methodically, and intentionally suppressed evidence of this ancient Martian society from the public for decades, emphasizing that the truth extended not only to Mars but to the Moon as well. Adding further intrigue to his biography, Hoagland claimed involvement in the creation of the Pioneer 10 plaque, a gold anodized aluminum message attached to NASA's Pioneer 10 spacecraft, launched in 1972. This plaque was intended to communicate basic information about humanity and our position in the galaxy to any extraterrestrial intelligence that might encounter the spacecraft. Hoagland asserted that he co-created the plaque with Eric Burgess in 1990. challenging the widely held belief that Carl Sagan received sole credit for the design. This personal involvement, he suggested, underscored his deeper connection to the mysteries of space exploration and his unique perspective on the potential for life beyond Earth. Returning to the enigmatic face of Mars, the ongoing debate highlights the tension between scientific analysis and human imagination. While NASA and most planetary scientists have maintained that the feature is an optical illusion shaped by natural erosion, shadow, and light, independent researchers have continued to scrutinize the area for additional anomalies. Surrounding the mesa, they have reported other formations that seem to resemble pyramids, fortresses, and structures arranged with suspiciously symmetrical geometry. To these observers, the apparent organization and alignment of the formations suggest not mere chance but intelligent design, further fueling speculation that Mars may once have hosted a complex civilization capable of creating monumental architecture. Even as more advanced imaging has been collected over the years, the Cydonia region retains a unique place in both scientific and popular culture. The original Viking images, now decades old, sparked an enduring fascination with Mars, bridging the gap between rigorous planetary science and the human imagination's fascination with mysteries of life beyond Earth. The interplay of shadow, light, and perspective, combined with the sheer scale of the Cydonian mesa, demonstrates how natural formations can evoke profound psychological and cultural responses. The saga of the Martian face continues to inspire debate about the nature of perception, the limits of scientific interpretation, and the possibility that Mars once held secrets now lost to time. The story also highlights the evolving capabilities of space technology, from the grainy 50-megapixel images captured by Viking 1 to the finely detailed 14-meter resolution photographs obtained from Mars Express. Humanity's tools for exploring Mars have grown dramatically more powerful, allowing for ever more precise mapping and analysis of the planet's surface. The creation of three-dimensional models and high-resolution topographical maps has revealed the subtle complexities of Martian geology, providing evidence that features once interpreted as artificial may have straightforward natural explanations, shaped by wind, erosion, and sediment deposition over millions of years. Yet, the allure of the unknown persists. The concept that an intelligent civilization could have once thrived on Mars captures the imagination, blending science, speculation, and storytelling in a way that few discoveries on Earth, or anywhere else, have managed to do. Proponents of alternative theories continue to point to geometric alignments, apparent pyramidal structures, and the haunting visage of the Cydonian mesa as evidence that something extraordinary may have existed on the Red Planet. Whether these formations are purely natural or remnants of a lost civilization remains a question that tantalizes enthusiasts and researchers alike. The debate over the face of Mars also serves as a case study in human perception. The phenomenon of pareidolia, by which humans instinctively recognize faces or familiar patterns in random arrangements, explains why so many see a face in a naturally occurring mesa. Yet, the persistence of alternative interpretations illustrates the human desire to find meaning and narrative in the unknown, to link disparate elements into a coherent story that transcends the ordinary. Could this face be a relic, a message, or the final trace left behind by a fading world? In the earliest days of human civilization, in the vast lands between the rivers we now call the Tigris and the Euphrates, ancient Mesopotamian peoples told stories that have fascinated humanity for thousands of years. These stories, recorded on clay tablets and preserved through the careful hands of scribes, spoke of mighty beings who came down from the heavens. They were described as gods, creators, and masters of life itself, figures who held knowledge far beyond that of ordinary humans. These beings were known as the Anunnaki, a name that echoed through the myths and legends of the Sumerians, Akkadians, Babylonians, and Assyrians. The texts attributed to them extraordinary powers. They were said to have descended from the sky to shape the early lives of humans, to guide, instruct, and sometimes even manipulate the path of humankind according to their own designs. They were not merely observers of humanity, but active participants in its formation, wielding skills that were beyond mortal comprehension. In modern times, this ancient mythology has been revisited through new lenses, blending history, archaeology, and speculative interpretations. One of the most well-known modern interpreters of the Anunnaki is Zecharia Sitchin, an author whose ideas sparked both intrigue and controversy. According to Sitchin, the Anunnaki were not supernatural gods at all, but rather extraterrestrial visitors from a distant, mysterious planet called Nibiru. This planet, he suggested, is part of our solar system, yet it moves in an extremely elongated orbit, visiting the inner planets only every few thousand years. Nibiru, he proposed, is not merely a celestial body, but the home world of an advanced species with knowledge and technology, far surpassing anything humans had at the time. Sitchin's theories suggest that these extraterrestrial beings came to Earth thousands of years ago for very practical reasons. Unlike the divine beings of mythology who act out of spiritual or moral purposes, the Anunnaki were here primarily to mine valuable resources, especially gold. Gold, according to these theories, was not just a material of wealth or decoration, but a resource crucial for the survival of their civilization, or for technological purposes that humans could scarcely understand. However, mining such vast quantities of gold required labour, and it is here that Sitchin makes one of his most controversial claims. The Anunnaki allegedly engineered humans to serve as workers. According to this line of thought, modern humans were created or genetically modified to be a labour force, capable of sustaining the mining operations that these extraterrestrial visitors undertook. In other words, humanity itself may have originated as a project, a carefully crafted creation designed to meet the needs of beings from another world. But the story does not end there. Sitchin and other theorists proposed additional ideas about the Anunnaki that are less well known but equally fascinating. They explored not only their possible motives but also the ways in which these beings might have influenced human culture, technology, and even the development of civilization itself. Temples, monumental architecture, the sudden leaps in knowledge during the early stages of Sumerian civilization. These could all, according to the theory, be traced back to contact with beings far more advanced than humans. While mainstream science and archaeology do not support these claims, the ideas persist in popular imagination, blending the allure of the ancient past with the mystery of the stars above. Interestingly, these ancient extraterrestrial theories intersect with modern human endeavours to reach and inhabit other worlds, particularly our own moon and the planet Mars. For decades, scientists and engineers have studied the feasibility of establishing human colonies beyond Earth. On the moon, projects have long been envisioned to sustain life, explore resources, and perhaps even develop permanent settlements. Achieving this, however, is no small feat. The moon lacks a breathable atmosphere, has extreme temperature swings, and receives frequent meteorite impacts, making life there challenging. Yet studies show that with careful planning, it is possible to create habitats that support human life, using technology to generate air, water, and energy. Mars presents an even greater challenge. Unlike the Moon, which is relatively close to Earth, resupplying a colony on Mars would be far more difficult, expensive, and time-consuming. The planet is millions of kilometers away, and spacecraft would take months to travel there. Despite these challenges, scientists have found that Mars is not entirely inhospitable. Vital resources necessary for human survival are present on the planet. Water exists in the form of ice at the poles and as traces of vapor in the atmosphere. The soil contains minerals that could be used to grow food, and with the right technology, humans could potentially live off the land, extracting air, water, and energy directly from the Martian environment. The idea that humans could settle on Mars is no longer science fiction. It is considered entirely feasible, provided the right infrastructure is in place. What makes Mars especially intriguing is its history. Today it appears as a cold, dry, and largely barren world, covered in rust-coloured dust and marked by vast deserts and frozen plains. It is a planet that, at first glance, seems inhospitable to life, yet geological evidence paints a different picture of the past. Not so long ago in the timeline of planets, Mars was a much warmer and wetter place. Rivers carved valleys into its surface, lakes filled basins, and oceans may have dotted its landscape. The skies could have been blue and occasionally cloudy, with seasons that were far more temperate than they are now. There is even the tantalizing possibility that simple forms of life, perhaps plants or microorganisms, once thrived on the planet. Researchers studying its surface find remnants of these watery landscapes, clues that Mars was not always the frozen desert we see today. Studies of Martian climate suggest that the planet is currently in the grip of an ice age. Similar to the ice ages experienced on Earth, Mars has periods of extreme cold interspersed with shorter intervals of relative warmth. Its climate is not identical to Earth's, however. Because Mars has a larger orbit around the Sun and a greater tilt of its axis, the swings between warm and cold periods are more severe. Zechariah Sitchin explains that much like Earth, Mars undergoes cycles of ice and warmth. On Earth, these cycles influence seasons, weather patterns, and the advance and retreat of glaciers. On Mars, the effect is even more dramatic. Scientists believe that these cycles, which last roughly 50,000 years each, dictate the long-term climate of the planet. When the next warm period, or interglacial, occurs on Mars, water will flow freely once again. The planet will experience milder seasons, and its atmosphere may become more suitable for human habitation than it is today. Determining the timing of past interglacial periods is critical for understanding Mars' history. Evidence suggests that the last warm period was not exceedingly distant, because otherwise the constant dust storms that sweep across the Martian surface would have erased much of the physical evidence of rivers, lakes, and ocean shorelines. The presence of water vapor in the atmosphere today also indicates that the planet has not been completely dry for millennia. Even the thin, seemingly inhospitable atmosphere contains resources that could support life. Water vapor can be condensed and collected, and the presence of oxygen, hinted at by the reddish, rusty color of the soil, which comes from iron oxidation, suggests that breathing and combustion are possible with appropriate technology. Long before modern theories emerged, astronomers speculated about the possibility of life on Mars. Before the famous writer Percival Lowell wrote about canals on the Martian surface in the late 19th century, many scientists had already wondered if the planet might be home to intelligent beings. Observations of Martian landscapes, its polar ice caps, and seasonal color changes led some to imagine a civilization adapted to the planet's environment. In 1871, for example, astronomer Elias Colbert conducted studies of the stars and planets and suggested that Mars could be suitable for rational beings similar to humans. He reasoned that the planet's extended habitable period and cooler climate might encourage intelligence and technological innovation. Colbert drew upon contemporary anthropological ideas, which, although now discredited, claimed that human societies in colder climates became more inventive and advanced because they were forced to solve challenges posed by harsh winters. Applying this logic to Mars, he speculated that a civilization there might be even more advanced than our own. These ideas, blending science and speculation, eventually found their way into popular imagination and fiction. The concept of technologically advanced Martians visiting or attacking Earth became a central theme in literature, most famously in H.G. Wells' book The War of the Worlds. In this story, alien invaders, sometimes described as squid-like creatures wearing mechanical suits, descend upon Earth to conquer and devastate humanity. While fictional, Wells's narrative reflects a fascination with extraterrestrial intelligence, the possibility of life on Mars, and the consequences of contact between civilizations of different technological levels. This interplay between scientific curiosity and imaginative storytelling has continued to shape human perceptions of Mars, influencing not only fiction, but also scientific inquiry, and even speculative theories about ancient visitors from space. Thus, the narrative of Mars, the Anunnaki, and human exploration is intertwined in multiple layers. The ancient texts describe gods descending from the sky, shaping humanity and guiding civilization. Modern interpretations suggest these beings were visitors from another world, mining precious resources and experimenting with life on Earth. Meanwhile, contemporary science and engineering explore humanity's potential to follow in these hypothetical footsteps, establishing colonies on the Moon and Mars, harnessing planetary resources, and learning to survive in environments that are harsh and alien. Mars itself becomes a mirror for human imagination, a canvas upon which myths, theories, and scientific studies converge. The planet's history, as revealed through geology and climate studies, offers both caution and hope. Its past warmth and flowing water suggest that habitable conditions are possible, while its current cold and dry state demonstrates the challenges that await anyone who would attempt to settle there. The atmosphere, though thin and seemingly toxic, contains water and oxygen, hinting that with technology and ingenuity, humans might indeed live off the land. Just as the Anunnaki were said to manipulate life and create humans for their purposes, modern humans now imagine themselves as creators in their own right, terraformers, engineers, and explorers who may one day leave Earth to inhabit worlds once thought unreachable. The cyclical nature of Mars' climate adds another layer of complexity. Unlike the steady seasons of Earth, Martian seasons are extreme, swinging between bitter cold and more moderate warmth over tens of thousands of years. Understanding these cycles is crucial for anyone planning to live there permanently. As Sitchin noted, the next warm period, or Martian interglacial, will bring flowing water, milder seasons, and a more Earth-like atmosphere. The timing of this period is uncertain, but the clues left in the planet's surface, ancient riverbeds, lake basins, and the continued presence of water vapour, suggest that it is within the realm of possibility for humans to exploit these resources in the future. In exploring these connections between myth, history, and science, we begin to see a fascinating tapestry of human curiosity. Ancient peoples looked to the sky and imagined gods descending from the heavens. Modern authors and theorists looked to ancient texts and imagined extraterrestrial visitors shaping our species. Contemporary scientists and engineers look at planets like Mars and the Moon and imagine humanity expanding beyond Earth, surviving, thriving, and perhaps even reshaping new worlds in our image. In every era, the unknown, the distant stars, the ancient past, the potential for life on other worlds, provokes wonder, speculation, and imagination. The Anunnaki, whether myth or reality, serve as a symbol of this enduring fascination. They represent the possibility that life, intelligence, and technology are not confined to our planet. They invite us to consider that humanity may have origins beyond Earth, and that our species might one day reach for the stars in ways that echo those ancient stories. Mars, with its frozen deserts, ancient river valleys, and subtle hints of a once habitable world, offers both a reminder of the challenges that lie ahead and a promise of opportunity. The planet challenges our ingenuity, tests our ability to survive in alien conditions, and beckons us to dream of a future in which humans are no longer confined to a single blue planet, but are citizens of a broader cosmic neighbourhood. Even the red dust of Mars tells a story. Its rusty colour, resulting from the oxidation of iron rocks, hints at the presence of oxygen, a vital element for life. The thin atmosphere, though seemingly harsh and dangerous, contains traces of a water vapour that could be condensed for drinking or used in agriculture. Scientists envision ways to extract oxygen for breathing, or even for generating energy. The resources are there, waiting for humans to unlock their potential, just as ancient myths suggested that powerful beings once harnessed the riches of the Earth and beyond. In sum, the story of the Anunnaki, Mars, and human exploration is a tale of continuity across time. It spans from the earlier civilizations that looked to the skies in awe, through centuries of scientific speculation and imaginative fiction, to the present era of ambitious plans to settle new worlds. It blends history, myth, science, and imagination into a single compelling narrative. Whether the Anunnaki were truly visitors from Nibiru, or merely a reflection of human creativity and storytelling, their legend continues to inspire our visions of life beyond Earth. The red planet, with its ancient rivers, icy poles, and faint atmosphere, becomes a symbol of both challenge and hope, a place where the line between myth and possibility grows thinner with every passing year, inviting humanity to explore, discover, and perhaps to live among the stars, just as the gods or visitors from other worlds were said to have done so long ago. Ultimately, Mars is more than a distant planet. It is a mirror of our curiosity, our ambitions, and our dreams. It challenges us to imagine life in extreme conditions, to devise technology that sustains human existence where none naturally occurs, and to ponder our origins and destiny in a universe far larger than our ancestors could ever have conceived. The interplay between ancient myths of the Anunnaki, the geological evidence of Mars' past, and modern scientific exploration creates a narrative that is simultaneously cautionary, inspiring, and endlessly fascinating. In this way, the story comes full circle. From the Mesopotamian clay tablets to the orbiters and rovers of the 21st century, humans have always looked upward and wondered what lies beyond. The Anunnaki, whether real or imagined, Mars with its frozen deserts and hidden water, and the vision of human colonies on other worlds, all speak to the same truth, that humanity is defined not only by its history, but by its curiosity, its imagination, and its willingness to explore worlds both old and new. In the end, whether we are uncovering ancient myths or planning the first footsteps on distant planets, we're continuing a journey that began long ago, a journey to understand the universe, our place within it, and the possibilities that await us among the stars. An American astronomer once wrote a lesser-known, yet surprisingly popular follow-up story about a Martian attack. In this tale, called Edison's Conquest of Mars, the famous inventor Thomas Edison takes the lead in fighting back against the Martians, taking the battle right to their planet. But before we get too caught up in science fiction, let's return to Zecharia Sitchin's theories about the Anunnaki and their presence on Mars as a possible extraterrestrial civilization. Mr. Sitchin presents many photographs of Mars, including images of its pyramids, the famous face on the surface, and other strange formations. He also shares the opinions of several experts who have studied these images. According to Sitchin, when the NASA scientist first examined the photograph of the Martian face sent by the Viking 1 orbiter, on the 25th of July 1976, he was reportedly stunned. The story goes that he almost fell out of his chair, exclaiming something along the lines of, "Oh my God," or other expressions of sheer amazement. Despite this initial shock, the photograph was simply filed away, along with thousands of other images from the Viking mission. The reason given was that the resemblance to a human face was considered nothing more than an optical illusion, just a play of light and shadows over a rock formation sculpted by natural forces like wind and water erosion. 3 years later, in 1979, Vincent DiPietro, an electrical engineer and imaging specialist, remembered seeing the face in a popular magazine. Curious, he decided to search through the archives of the National Space Science Data Center. There, he finally came face to face with the Martian image. Intrigued by the fact that the photo had been quietly stored under a caption, hinting at the existence of a head that many had long denied, DiPietro teamed up with Greg Molinar, a computer scientist at Lockheed. Together they began a determined search for the original NASA image. Their efforts revealed something remarkable. They discovered not just one, but 2 images of the Martian face. The second, less known, was recorded as image 070-A-13, plate F. Through their careful investigation, DiPietro and Molinar brought new attention to a mysterious feature on Mars that had quietly waited for decades to be studied more closely. After the first startling image of what seemed to be a colossal human-like face on Mars emerged from the Viking 1 spacecraft in the mid-1970s, curiosity and speculation about this unusual landform only grew. Scientists and enthusiasts alike began to look closer at the Cydonia region, the place where this enormous visage had been recorded, measuring over 2 kilometers across, an astonishing scale that dwarfed any human-built monument on Earth. Subsequent missions and photographic surveys did not disappoint in adding layers of detail to this growing mystery. Different Viking orbiter cameras, observing from varying angles and positions, captured multiple images of the same area. These images were taken not just from a single perspective, but from both the right and left sides of the prominent features, giving researchers a more complete understanding of their 3-dimensional shapes. By the early 1980s, there were 11 known images of the Cydonia area, in which the enigmatic face could be observed, accompanied by additional structures that seemed to rise from the Martian plains like miniature pyramids or other geometric formations whose origins were far from obvious. The accumulation of photographic evidence inspired a team of independent researchers to study the images with extraordinary care. Among them were Vincent DiPietro and Gregory M. Molinar, 2 individuals who approached the data with both curiosity and technical rigor. They employed sophisticated computer enhancements, digital filtering, and other imaging techniques that were cutting edge for the period. These methods allowed them to enlarge the images, sharpen details, and remove some of the distortions caused by light, shadow, and the limitations of orbital photography. What emerged from these efforts was astonishing. The Martian face in its clearer form displayed features that seemed to follow a deliberate symmetry. The The eyes, nose and mouth suggested proportions too precise to be easily explained as a mere trick of light on a rocky hill. Di Pietro and Molinar became convinced that these were not random geological formations. In their eyes, the face had been artificially sculpted, possibly by intelligent beings who had once walked the surface of Mars. With their findings in hand, the pair decided to bring their observations to the broader scientific community. In 1981, they attended the Case for Mars conference, a gathering intended to explore the latest developments in Martian research. Yet, despite the potential significance of their discovery, they were met not with applause or curiosity, but with a chilling indifference. Many of the attending scientists regarded the suggestion that an intelligent species could have once inhabited Mars as inconceivable. Accepting such an idea would have upended fundamental assumptions about the planet, the origins of life, and the uniqueness of humanity itself. Consequently, instead of engaging with the evidence, the conference participants largely ignored or dismissed Di Pietro and Molinar's claims. The authors, recognizing the bias they faced, carefully noted in their book, Unusual Mars Surface Features, particularly in its epilogue, that they were not claiming to have irrefutable proof of intelligent life on Mars. Their position was much more modest. The Martian face and accompanying structures did not appear to be natural formations, and they strongly suggested that these features deserved further and more thorough investigation. NASA, however, was less accommodating. The agency consistently rejected any notion that future missions should devote resources to studying the face directly. According to NASA's official position, the Martian face was simply a mountain shaped by ordinary geological processes. In other words, it was a natural rock formation that happened, through the random forces of erosion and deposition, to resemble a human face. To most official researchers, entertaining the idea of ancient Martians was not merely improbable, it was scientifically unacceptable. Despite this institutional resistance, interest in the Martian face persisted. One of the most persistent and vocal proponents of the artificiality hypothesis was Richard C. Hoagland, a figure previously mentioned in discussions of Mars anomalies. Hoagland approached the mystery with a combination of technological savvy and an eye for interdisciplinary collaboration. He organized a conference and working group called the Independent Mars Investigation Team, designed to pool expertise from a wide array of scientists and specialists. The goal was simple yet ambitious: to study the unusual features of Mars in a structured, rigorous, and unbiased way. Over time, the team attracted notable participants, including Brian O'Leary, a scientist with astronautical experience, and David Webb, who had served on the United States President's Space Commission. These were individuals with the training, credibility, and investigative rigor necessary to evaluate anomalous findings with the seriousness they deserved. The conclusions of Hoagland and his collaborators were as bold as they were controversial. Not only did they support the idea that the Martian face and pyramid-like structures were artificially created, but they also suggested that numerous other formations on Mars's surface bore the marks of intelligent design. Their reports proposed that these structures were not merely incidental geological coincidences, but the remnants of a civilization that had once thrived on the planet. Perhaps most astonishingly, they speculated on the age and purpose of these formations. Based on the orientation of the face and the principal pyramid relative to the Martian sun, they estimated that these structures had been constructed approximately 500,000 years ago. Their alignment appeared to correspond with the sunrise at solstice, hinting at an advanced understanding of astronomy and engineering by the beings who created them. This hypothesis, however, remained highly controversial. NASA, steadfast in its dismissal of any notion of Martian civilization, strongly contested these interpretations. The agency's position, in essence, was that there was no compelling evidence for ancient intelligent activity on Mars, and that all unusual features could be explained by natural geological processes. The debate became so contentious that NASA took the unusual step of actively responding to the public interpretations advanced by Di Pietro, Molinar, and Hoagland. The National Space Flight Center in Greenbelt, Maryland, which served as a primary source for the public to access NASA data, began enclosing official rebuttals alongside copies of the Martian face photographs. These rebuttals were detailed, carefully argued documents aimed at countering claims that the images showed anything beyond ordinary rock formations. One such rebuttal was a 3-page paper authored by Paul Butterworth, dated June 6, 1987. Butterworth, described as the centre's resident planetary scientist, argued that there was no reason to believe the Martian face differed in origin from the tens of thousands of other mountains scattered across the planet. According to him, geological forces over millions of years could easily produce shapes that, under particular lighting conditions, appeared to mimic human features. In other words, the face was nothing more than an extraordinary example of nature's capacity to generate patterns that deceive the eye, a phenomenon known in scientific circles as pareidolia. Despite these official challenges, independent research continued to suggest otherwise. A particularly influential study was conducted by Mark J. Carlotto, an expert in optics and imaging. His work was published in May of 1988 in the prestigious journal Applied Optics, a publication known for its rigorous peer review standards. Carlotto's study analysed the Martian face using quantitative methods designed to detect symmetry, proportions, and structural coherence. What he found was striking. The formation exhibited bilateral symmetry, clearly defined features resembling human eyes, a nose and a mouth, and even a suggestion of teeth in the shaded area of the mouth. Carlotto concluded that these characteristics were not random or transient effects caused by sunlight and shadow. Rather, they were the markers of deliberate design, encoded in the terrain itself, and could not be easily dismissed as illusions. The story of the Martian face did not exist in isolation. Across the Cydonia region, numerous geometric formations, including pyramid-like structures and terraces, seemed to suggest a larger pattern of intelligent activity. If these formations were indeed artificial, then they hinted at an advanced civilization that had emerged on Mars long before humans ever looked up at the stars from Earth. For decades, mainstream scientists avoided this possibility, perhaps because its implications were too extraordinary. Evidence of a technological society that flourished on another planet, only to vanish into the annals of cosmic history. Public fascination with the Martian face and related anomalies intensified as news of the debate spread. The clash between official NASA positions and the claims of independent researchers created a tense narrative. On one side, the authoritative voices of established science insisting on natural explanations, and on the other, a growing cadre of investigators who saw in the Martian surface the unmistakable fingerprints of intelligent life. This dynamic shaped popular perceptions of Mars, fueling documentaries, articles, and later books and lectures, all attempting to make sense of the vast red landscape seen from orbit. By the late 1980s, the conversation had grown to encompass not just individual images, but the broader implications for humanity's understanding of its place in the universe. If Mars once hosted a civilization capable of constructing monumental architecture aligned with celestial events, what did that say about life's potential across the cosmos? Was Earth truly unique, or merely one of many worlds where intelligent life could flourish and then fade into obscurity? These questions, once confined to science fiction, now hovered at the edge of serious scientific inquiry, thanks largely to the persistence of researchers like DiPietro, Molyneux, Hoagland and Carlotto, who refused to ignore anomalies that defied conventional explanations. In addition to photographic evidence and optical studies, the methodologies applied by these investigators were increasingly sophisticated. Computer enhancement techniques allowed for three-dimensional modelling of the Martian terrain, offering the possibility of virtual exploration long before rovers could physically traverse the landscape. Shadows, angles and elevation data could be reconstructed digitally, revealing subtle details that were invisible in the original orbital images. These reconstructions strengthened the argument that the Cydonia face and pyramids were not mere illusions. Their proportions, orientation and context suggested deliberate construction, yet skepticism remained a defining feature of the scientific response. Critics argued that humans are naturally predisposed to see patterns where none exist, a cognitive bias that can lead even trained researchers to overinterpret ambiguous stimuli. This tension between enthusiasm for discovery and the demand for methodological rigour became a hallmark of the debate surrounding the Martian face. It was a debate not only about Mars itself, but about the boundaries of human knowledge, the willingness to challenge orthodox narratives, and the courage to confront possibilities that stretch the imagination. Through all of this, the narrative of Mars evolved from a barren, lifeless planet into a stage upon which mysteries both natural and potentially artificial played out. The Cydonia face became emblematic of this transformation, a symbol of inquiry, controversy, and the tantalizing possibility that the story of life in our solar system was far richer than anyone had imagined. Whether or not future missions would ever definitively prove the existence of an ancient Martian civilization, the evidence gathered and analysed during these decades left an indelible mark on how humanity approached the Red Planet. It demonstrated that even in the most inhospitable environments, structures might endure across eons, silently telling the stories of civilizations lost to time, waiting for observant eyes to recognise their significance. In retrospect, the saga of the Martian face illustrates the interplay of technology, interpretation, and imagination. From the initial orbital images of 1976 to the enhanced analyses of the 1980s, each step in the journey combined human ingenuity with the raw data of a distant world. Di Pietro and Molinar's insistence on careful study, Hoagland's organisational initiative and Carlotto's rigorous optical analysis together built a multifaceted case that, at minimum, called for further exploration. The scientific world paid close attention when a remarkable study concerning the enigmatic formations on the surface of Mars was published. The journal Applied Optics considered the research so significant that it featured the work prominently on its front cover, an honour reserved only for studies deemed extraordinary. The popular scientific magazine New Scientist also devoted a special report to the publication, dedicating space not only to the paper itself, but also to a detailed interview with its author. Both publications highlighted the author's suggestion that these puzzling formations, the so-called Martian face, and the nearby pyramidal structures, which some observers had begun to refer to collectively as the Martian City, warrant careful attention from future exploratory missions to Mars. Among these missions were the Soviet Phobos program, which was scheduled for launch in 1988, and the American Mars Observer mission. In addition to Western recognition, the study received notable attention in the Soviet scientific community. The controlled press of the Soviet Union had repeatedly published and republished articles by Vladimir Ainsky, a distinguished researcher in geology and mineralogy, who supported the idea that the Martian monuments were not natural formations. The consistent attention in the Soviet media strongly indicated the interest of the Soviet aerospace authorities in this phenomenon, a subject that warrants far deeper exploration. Ainsky emphasized a unique aspect of Martian conditions, the planet's lower gravity. He argued that, under such conditions, a human could perform tasks of immense scale that would be impossible on Earth. To him, this physical fact provided a plausible explanation for how such gigantic monuments could exist on the surface of Mars. Among the most intriguing features in the Martian complex, he noted, was a dark circle clearly visible on the flat terrain situated between the face and the pyramidal structures. While NASA scientists dismissed this circle as a mere smudge of water on the camera lens of the Viking orbiter, Ainsky regarded it as the central point of the entire Martian layout, the very heart around which the surrounding structures seemed to be arranged. The implications of these observations led to profound questions about history and the origins of intelligent life. Unless one were to assume that Earth itself had hosted a highly advanced civilization tens of thousands, or even hundreds of thousands of years ago, civilizations capable of space travel and able to construct monumental works on another planet, then only two logical possibilities remained. The first was that intelligent beings had evolved independently on Mars. These beings would not only have had the technology to create massive megalithic constructions, but would also have resembled humans in appearance. Yet this scenario faced serious challenges. Mars, as explored through modern probes, appeared devoid even of the simplest microorganisms, lacking any vegetation or animal life that could provide nourishment to a human-like species. The evolution of a Martian population analogous to that of Earth, one capable of duplicating the architectural forms found on our planet, seemed exceedingly improbable. This left a single remaining plausible hypothesis, that visitors from neither Earth nor Mars, possessing advanced technology and capable of interplanetary travel hundreds of thousands of years ago, had journeyed through the solar system, stayed for a period, and constructed monumental works on both Earth and Mars. The only known beings from ancient records, mythology, and historical texts that fit such a description were the Anunnaki of Nibiru, Ancient Sumerian writings, biblical references, and myths from cultures across the globe repeatedly alluded to these beings, often described as descending from the heavens to interact with early humanity. The connection between Earth and Mars became even more intriguing when one considered the orientation of the monuments. The Great Sphinx of Giza, for example, was carefully aligned to face eastward along the 30th parallel, precisely oriented toward what some interpretations suggest was a spaceport used by the Anunnaki in the Sinai Peninsula. If the Sphinx represented a fair of face, a messenger transmitting divine commands, then could the Martian face have served a similar purpose? Could it have been designed to transmit a message from the heavens to the Sphinx on Earth, acting as a cosmic relay from one fair of face to another? If this were the case, then it would make sense for pyramidal structures to accompany the Martian face, just as pyramids accompany the Sphinx at Giza. Remarkably, Dr. Ainsky identified 3 structures near the Martian face that could be considered true pyramids, echoing the layout of the Giza Plateau. This observation aligned with the work of Zecharia Sitchin, who in his volumes of the Earth Chronicles series argued that the Giza pyramids were not the creation of pharaohs, but were instead constructed by the Anunnaki. According to Sitchin, these extraterrestrial beings had travelled to Earth to exploit resources, particularly gold, and to construct facilities and monumental structures to aid in their operations. In the Sinai Peninsula, for instance, the Anunnaki reportedly established infrastructure to transport gold from southern Africa to their home planet of Nibiru. In other regions, such as the mountains and plains of South America, they engaged in extensive mining operations, building monuments in the process. Sitchin extended this logic to Mars. Of the numerous unusual features captured by orbiting cameras on the Martian surface, he identified at least 2 that appeared almost certainly artificial. Fascinatingly, both of these formations seemed to mimic architectural patterns found along the shores of Lake Titicaca in the Andes, suggesting a thematic continuity in construction techniques across planets. Sitchin provided illustrations and detailed sketches to support these assertions, making a compelling case that the similarities were unlikely to be coincidental. The reasoning could be framed in a practical sense. If an alien spacecraft were to search for evidence of intelligent life on Earth, it might look for linear patterns such as roads, agricultural terraces, and other rectilinear arrangements, signs that organisms had modified their environment in organized ways. NASA itself had inadvertently provided analogous evidence for potential intelligent activity on Mars. One frame, numbered 5235, displayed a series of parallel grooves in the terrain, resembling carefully contoured farmland akin to that found in the Sacred Valley of Peru, high in the Andes. Such patterns, whether natural or artificial, hinted at the possibility that the surface of Mars might have been deliberately shaped by intelligent beings. Sitchin also drew attention to ancient Sumerian understandings of planetary order. The Sumerians counted the planets from the outside inward, placing Mars as the 6th planet from their perspective and symbolizing it with a 6-pointed star. Using these symbolic clues, one can examine depictions on cylinder seals from Sumerian culture, which astonishingly show a spacecraft with extended solar panels and antennas passing between Mars, represented by a 6-pointed star, and Earth, marked by 7 dots. In one depiction, a winged Anunnaki is shown greeting another figure in a helmet near these planetary symbols, reinforcing the interpretation that ancient peoples recorded not only their myths, but also cosmic knowledge of interplanetary visitors. The implications of all this are profound. If the Martian face, its surrounding pyramids, and other nearby structures were indeed constructed by beings capable of interplanetary travel, then the story of intelligent life in our solar system is far richer and more complex than modern science has acknowledged. We are faced with the possibility that long before human civilization arose on Earth, beings from beyond our world had traversed the heavens, leaving behind traces of their presence both on our planet and on Mars. These traces, embedded in monumental works, symbols, and perhaps even the topography itself, suggest a deliberate communication, a network of messages spanning planets, connecting the Sphinx at Giza to the mysterious formations of Cydonia. Considering the careful alignment of structures, the apparent artificiality of the Martian face, and the presence of accompanying pyramids, the evidence encourages serious scientific inquiry. Ainsky's observations and Sitchin's interpretations together point toward a conclusion that challenges conventional assumptions. If intelligent life capable of megalithic construction existed on Earth hundreds of thousands of years ago, it was not native to our planet but part of a wider interplanetary presence. The dark circle between the face and the pyramids, dismissed by some as a mere artifact of photography, may in fact represent the centre of a deliberate design, the focal point of an ancient architectural scheme. Moreover, the similarities between the features on Mars and structures on Earth, from Lake Titicaca to the Giza Plateau, suggest a coherent pattern of construction and purpose. If these parallels are not coincidental, they imply a civilization that applied consistent architectural principles across vast distances of space and time, leaving behind markers meant to be seen by future generations. Whether these markers served practical functions, ceremonial purposes, or even acted as messages between planets, they undeniably point to an intelligence far beyond what traditional archaeology and planetary science have considered. Ultimately, the only beings for which we have historical, mythological, and textual evidence that might account for these extraordinary phenomena are the Anunnaki. From Nibiru, they are said to have visited Earth and Mars, constructing monuments, establishing mining operations, and leaving symbolic records of their presence. These ancient texts, both Sumerian and biblical, together with the mythologies of numerous cultures, provide a consistent narrative of a spacefaring civilization that influenced human history and, possibly, the development of civilizations across the solar system. The Martian face, the nearby pyramids, and other anomalies captured by orbiters therefore demand serious scientific investigation. The extraordinary alignment, apparent artificiality, and correlation with structures on Earth suggest a deliberate design and an intelligence behind their creation. Whether these formations were intended as markers, messages, or memorials, they represent evidence that Mars too was once touched by the hands of intelligent beings, perhaps the same beings who shaped human history, guided early civilizations, and left a legacy that reaches across the stars. So why was Mars so important to them, and how did they know so much about it? Billions of years ago, long before humans walked the Earth, Mars was a very different world. It was not the cold, lifeless desert we see today, with its rust-red sand and endless dust storms. Instead, it was a planet that had all the ingredients necessary to support life. Rivers may have flowed across its surface, lakes may have reflected the pinkish sky, and perhaps even vast oceans stretched across its plains. The air was thicker, warmer, and richer in gases that could sustain living creatures, and it was protected by a magnetic field strong enough to shield the planet from deadly cosmic radiation. Mars, in its youth, was a world teeming with potential. Its core was alive, churning with molten rock and generating a magnetic field. Its surface was sculpted by water and wind, and its climate may have been mild enough to allow life to flourish. The conditions were almost Earth-like in many ways, though the red planet had its own unique character, painted in shades of rusty crimson and ochre. Then catastrophe struck. Some event, or perhaps a combination of events, began to strip Mars of its vitality. Its atmosphere thinned, its magnetic field faded, and its core, once a furnace of activity, started to die. Radiation from the sun and cosmic rays raged across the surface, unfiltered, bombarding the planet and gradually sterilizing it. Dust storms, some of them gigantic and lasting for months, began to sweep across the landscape, reshaping the land and choking the skies. In a geologically brief moment, the thriving, life-friendly world began to deteriorate into the barren wasteland that humanity observes today. But before this decline, there is a possibility that life existed on Mars. Perhaps simple organisms, small and hidden from view, inhabited its surface or lived underground. Scientists continue to ponder what life on Mars might have looked like, whether it was microbial or more complex. The idea that life could have once thrived there is not just a flight of fancy. Evidence collected from orbiting spacecraft, landers and rovers has shown that the planet's surface bears unmistakable marks of rivers, lakes, and possibly even oceans. These were not fleeting features, but long-standing bodies of water that carved valleys, shaped canyons, and left sediments behind, sediments that could have harbored microscopic life. One of the most dramatic events in Mars's more recent history, on a cosmic scale, occurred just over 2 million years ago. A giant asteroid, a rock of unimaginable size hurtled through space and slammed into the equatorial region of the planet. The impact was catastrophic. It carved one enormous main crater, now known as Corinto, and left behind around 2 billion smaller craters scattered across the surrounding terrain. These secondary craters, which vary in size from roughly 656 feet to nearly 1 mile across, form an extensive ray system radiating outward from the impact site. The reach of these craters is staggering, covering an area of approximately 1,000 miles, or about 1,800 kilometers. The event was so massive that it is considered one of the largest asteroid impacts recorded on Mars in relatively recent history. Scientists estimate that asteroids capable of causing such widespread destruction strike the planet roughly once every 3 million years, making this event an extraordinarily rare occurrence. The impact struck a region that humanity has named Ilium Planitia, a broad plain near the equator of Mars. Corinto, the main crater, is immense, a scar etched into the planet's crust by the force of a collision that released energy beyond human comprehension. Surrounding this main crater, the secondary craters, formed either by debris ejected from the primary impact or by smaller fragments breaking off from the asteroid, stretch outward in all directions. Some of these secondary craters even cut through ancient lava flows that originated from the summit of Elysium Mons, one of Mars's extinct volcanoes, showing that these formations, though over 2 million years old, are astonishingly well preserved. Scientists describe them as geologically young, a term meaning that despite their age, they have retained their shape and definition in a way that most Martian features of similar age do not. This relative youth makes them a fascinating subject for planetary geologists studying Mars's violent past. Beyond these violent impacts, there is another thread of evidence suggesting that Mars may have been home to life long before the asteroid strike. A groundbreaking study published in the year 2020 in the journal Nature Astronomy explored the possibility that, billions of years ago, Mars might have harboured subterranean microbial life. These microbes, scientists speculate, could have been methanogenic, organisms that produce methane as a byproduct of their metabolism. On Earth, similar microbes exist in extreme environments, surviving in dark caves, deep under the ocean floor, and even in frozen tundras. If such microbes existed on Mars, they would have lived beneath the surface, shielded from the harsh radiation and storms above, slowly metabolizing and shaping their underground environment. Methane, the gas these hypothetical Martian microbes could have produced, is not merely a byproduct, it is also a climate driver. On Earth, methane plays a significant role in warming the atmosphere. On Mars, however, it may have had a different effect. Some scientists suggest that the methane released by these microbes might have interacted with the Martian atmosphere in ways that destabilized it over time. In a tragic irony, the very organisms that might have brought life to the planet may have contributed to the decline of their own habitat, releasing gases that altered the atmosphere and made the surface increasingly inhospitable. It is a haunting thought, life arising on a planet only to eventually accelerate its own demise. As centuries and millennia passed, Mars transformed from a potentially vibrant world into the frozen desert observed by humans today. Temperatures dropped dramatically, water disappeared from the surface, and the atmosphere became thin and unbreathable. Yet traces of the planet's past remain. Satellite images show dry riverbeds and ancient deltas. Craters and lava flows are etched into the surface like scars, telling a story of violent collisions, flowing water, and shifting landscapes. There are also tantalizing hints that the planet's surface may once have supported life, not just microbial, but perhaps more complex, even intelligent forms. Some researchers and writers have speculated that Mars might have been home to the Anunnaki, the mysterious beings described in ancient Mesopotamian texts as gods or visitors from the heavens. According to these accounts, the Anunnaki were not ordinary gods but extraterrestrial beings from a distant world called Nibiru. They arrived on Earth in the distant past, shaping early human civilization and leaving behind myths that humans would later interpret as divine. Some theories suggest that before coming to Earth, these beings may have had a presence on Mars. The planet could have hosted their colonies, research outposts, or even thriving settlements. Mars, with its rivers, lakes, and hospitable climate, would have been a perfect place for them to experiment with life, test genetic engineering, or simply live. However, When Mars became uninhabitable, when the atmosphere thinned, the magnetic field died, and the surface was bombarded by radiation, the Anunnaki may have been forced to leave. Their once great colonies would have been abandoned, and the planet, now a lifeless desert, would have been left behind. Earth then became their new home, a laboratory for their experiments, and humans became the subjects of their ongoing study. Whether this narrative is factual or symbolic, it has captured the imagination of many, linking the mysteries of Mars with the earliest myths of human civilization. Even today, exploration of Mars continues to reveal new surprises. Robotic rovers and orbiters scan the surface, probing the geology and chemistry of the planet, searching for signs of past water, organic compounds, and even microbial life. Each discovery adds to the picture of a planet that was once active, dynamic, and potentially alive. From the largest volcanoes in the solar system to the deep valleys carved by ancient rivers, every feature of Mars tells a story of transformation, survival, and loss. The scars of asteroid impacts like the one that created Corinto shows us that the planet has endured violent upheavals, while the traces of ancient water hint at a gentler, life-giving past. The idea that life may have existed on Mars is more than a scientific curiosity. It is a question that touches on our understanding of life itself. Could life have arisen independently on two planets in the same solar system? If methanogenic microbes once lived beneath the surface, producing gases that shaped the planet's atmosphere, what might that tell us about the resilience of life in extreme conditions? And if intelligent beings, whether real or mythological, once walked the Martian plains, what does that imply about the potential for civilizations to rise and fall on worlds beyond our own? Today, Mars is cold, dry, and barren. Its skies are muted pink, dust storms occasionally sweep across the plains, and the surface is littered with rocks and ancient craters. Yet, the imagination cannot help but wander, picturing rivers flowing through valleys, lakes shimmering under the faint sunlight, and microbial life hidden beneath the ground, quietly altering its environment. Perhaps somewhere deep in the Martian subsurface, remnants of past life remain, waiting for humans or future explorers to uncover them. The story of Mars is a story of possibility and loss. It is the story of a planet that had everything necessary to support life, only to be transformed by cosmic events and geological decay. It is a story of catastrophic asteroid impacts, of a vibrant past now reduced to ruins, and of a mystery that stretches across billions of years. Mars challenges humanity to think not only about the origins of life, but also about the fragility of planetary environments and the forces that can shape the destiny of worlds. In this sense, the Red Planet is a mirror for our own hopes and fears. It shows what a world can be in its youth, alive, flowing with water, potentially teeming with life, and what it can become if its protective shields fail and its core dies. The tales of the Anunnaki add another layer to the mystery, suggesting that Mars may have once been a cradle of intelligence, an experimental ground for beings capable of influencing life across planets. The planet's present desolation is stark, but its past is rich with the echoes of rivers, the footprints of asteroids, and the whispers of possible life, both microbial and perhaps even intelligent. As humans continue to explore Mars, sending more sophisticated robots, orbiters, and potentially even people, we may one day uncover definitive evidence of what the planet once was. We may find traces of ancient water, signs of long-extinct microbes, or even remnants of civilizations long gone. Each new discovery will bring us closer to understanding the full story of Mars, a planet that was once alive, that endured catastrophic events, and that may still hold secrets deep beneath its cold, red surface. The vision of a world once flowing with rivers, shaded by clouds and home to life, challenges humanity to imagine not just what Mars is today, but what it was billions of years ago, and what it might have meant to beings who once walked its plains. Could humanity be the legacy of Martian survivors? In the early years of the 21st century, a new chapter in humanity's fascination with Mars unfolded. In 2001, NASA returned to the enigmatic region of Cydonia on the Red Planet using its Mars Global Surveyor spacecraft. Scientists and space enthusiasts alike were eager to see what new details this advanced instrument might reveal. Yet when the images came back, the results were puzzling. A formation that had previously been interpreted by some as a face, an uncanny arrangement of hills, valleys and shadows, now appeared different. Blurry, weathered, eroded by the relentless forces of Martian wind and dust over millions of years, the so-called face on Mars seemed almost unrecognizable. NASA quickly assured the world that the formation was merely a natural rock formation, sculpted over eons by erosion and the harsh Martian climate. The words were simple but dismissive, just a rock. Yet this explanation did not satisfy everyone. A growing number of critics argued that the new images had been manipulated or altered, perhaps to hide something more extraordinary. They claimed the photographs had been airbrushed to eliminate anomalies, subtle hints of something remarkable that lay beneath the Martian surface. Among those who fueled these suspicions were whistleblowers, people who claimed to have seen hidden files and evidence that governments preferred the public never to know. One of the most famous of these whistleblower stories involved a man named Gary McKinnon, a quiet British hacker whose online exploits would later become legendary. McKinnon's interest in the Red Planet was entwined with his lifelong fascination with UFOs and extraterrestrial life. He believed that governments were concealing knowledge of alien technology, advanced energy systems, and even evidence that Mars had once been home to life. According to McKinnon and those who followed his claims, the truth about the Martian face was being deliberately hidden, and NASA, along with various branches of the United States military, had gone to great lengths to obscure it from public view. But who exactly was Gary McKinnon, and how did he manage to gain access to some of the most secure computer networks in the world? The story of McKinnon begins in London, where he lived a relatively quiet life in a modest apartment. By the year 2000, he was a 36-year-old Scotsman with an unassuming appearance, elfin features, upswept eyebrows dotted with small spots, and a calm, almost boyish demeanour. Though once a systems administrator, McKinnon was unemployed at the time, and much of his life revolved around the pursuit of his obsession with extraterrestrial phenomena. Night after night, he would immerse himself in research, reading everything he could about UFOs, anti-gravity technologies, and government secrecy. His curiosity was methodical and intense, fueled by a desire to uncover information that he believed had been deliberately hidden from the public. In February of 2001, McKinnon embarked on a digital journey that would shock the world. Using a combination of self-taught programming skills, intuition, and techniques he had gleaned from classic hacker manuals such as the Hacker's Handbook, McKinnon set out to explore the computer networks of the United States government. His stated goal was straightforward yet audacious. He wanted to find evidence of UFOs, extraterrestrial technology, and advanced energy systems that he believed were being suppressed. For months, he scanned thousands of government computers, uncovering glaring security flaws and astonishingly lax practices. Many federal employees had failed to change default passwords, leaving vast numbers of sensitive systems exposed. With the skills he had developed, McKinnon crafted scripts in the Perl programming language, small but powerful pieces of code that allowed him to scan tens of thousands of machines in mere minutes. He installed a program called Remotely Anywhere on vulnerable systems, giving him the ability to access computers from a distance, monitor activity, copy or delete files, and observe the operations of the networks without leaving a trace. Though, as it would turn out, he was not entirely careful in covering his tracks. Over the course of more than a year, between February of 2001 and March of 2002, McKinnon accessed nearly 100 computers across the United States Army, Navy, Air Force, NASA, and the Department of Defense. He moved silently through digital corridors, logging off whenever anyone else approached, and recording what he claimed to be extraordinary evidence. At one point, his intrusion caused the entire network of the United States Army in Washington, D.C. to crash, taking roughly 2,000 computers offline for 3 days. McKinnon's discoveries were startling, at least by his account. He claimed to have found files listing the so-called non-terrestrial officers of the United States Navy, officials who, according to these documents, were not of human origin. He also reported seeing photographs of UFOs, including cigar-shaped craft stationed near geodesic domes, a visual that he desperately wanted to save but could not due to the files being encoded in JavaScript. Perhaps most significantly, McKinnon maintained that he had glimpsed information suggesting a hidden trove of advanced technologies, some of which involved anti-gravity propulsion systems. In interviews, he insisted that his hacking was not motivated by personal gain or malice, but by a desire to bring hidden knowledge to humanity, believing that the information he uncovered could help advance civilization. McKinnon's activities did not go unnoticed. Within months, investigators traced his digital footprint to his apartment in London. In March of 2002, the United Kingdom's National High-Tech Crime Unit arrested him. The quiet Scotsman spent a brief period in Brixham Prison while legal proceedings unfolded. The revelations of his hacking spree stunned the public, especially the scale of his access and the audacity of his mission. Yet despite the media coverage and McKinnon's claims, much of the information he purportedly uncovered remains officially classified. The details about what lies beneath the surface of Mars, or within NASA's files, continue to be shrouded in secrecy. This veil of confidentiality has fueled speculation and imagination. What exactly are scientists and governments hiding beneath the Martian dust? And why is it so important to keep it secret? Meanwhile, NASA's own ambitions for Mars continued unabated. The agency has long envisioned sending humans on a scientific mission to Mars, with preliminary plans suggesting that such a journey could occur as early as the year 2035. The mission would be colossal in scope. Astronauts would endure a voyage of roughly 6 to 7 months each way, covering approximately 250 million miles, or about 402 million kilometers, one way. Upon arrival, they might spend as long as 500 days exploring the planet's surface, conducting experiments and searching for signs of past or present life before making the long return journey to Earth. To prepare for such an unprecedented mission, NASA launched a multi-stage program that involved returning humans to the Moon. The Artemis program, named after the twin sister of the Greek god Apollo, serves as a training ground for future Martian explorers. Astronauts living and working on the Moon will practice living in reduced gravity, navigating harsh terrain, and operating in isolated conditions similar to those expected on Mars. NASA's Space Launch System, a powerful new rocket, and the Orion spacecraft designed to carry humans into deep space are central to these plans. In November of 2022, the Space Launch System and Orion successfully lifted off on the Artemis 1 mission, an uncrewed flight that travelled to the Moon. Orion orbited the lunar surface for 6 days, reaching as close as 80 miles, or approximately 129 kilometers, above the Moon before returning safely to Earth on December 11th of the same year, after a maiden journey covering roughly 1.4 million miles, or approximately 2.2 million kilometers. The Artemis program is not simply about reaching the Moon. It is about preparing for the monumental challenge of human exploration of Mars. Subsequent missions, such as Artemis 3, scheduled for 2026, will land astronauts at the Moon's south pole. This area is of particular interest because it may contain large deposits of subsurface water in the form of ice. Astronauts will have the opportunity to mine, melt, purify, and use this water, practicing critical survival techniques needed for long-duration missions on Mars. They will establish habitats, explore the lunar surface, and develop the skills and knowledge required for extended stays on another world. In essence, the Moon becomes both a laboratory and a rehearsal stage for the ultimate goal, the exploration of Mars. The scientific objectives for a future Martian mission are as ambitious as the logistical challenges. NASA established a specialized panel, the Human Exploration of Mars Science Analysis Group, tasked with defining the most critical research questions that necessitate human presence rather than robotic missions. Among these questions is the search for life, past or present. Scientists know that life on Earth formed roughly 3.8 billion years ago, during a time when both Earth and Mars shared similar conditions: abundant liquid water, thicker atmospheres, and climates capable of sustaining microbial and potentially more complex life. Mars, however, underwent dramatic environmental changes, losing much of its water and atmosphere over time. Understanding these processes is crucial for comprehending not only Mars' history, but the history of Earth and the potential for life elsewhere in the universe. The tantalizing possibility remains that beneath the Martian surface, hidden in regions like Cydonia, there may be remnants of an ancient civilization or signs of biological activity. Some speculate that the face on Mars is more than a geological formation. It could be a monument, a warning, or even a record left by intelligent beings that once walked the planet. Whistleblower claims, combined with the extraordinary reports from hackers like McKinnon, suggest that there is far more to Mars than meets the eye. Artifacts, buried chambers, and vaults of knowledge might lie beneath the rust-coloured dust, waiting to be discovered. As NASA and other space agencies develop the technology and plan missions for humans to visit Mars, the world can only imagine the discoveries that await. Astronauts may one day land near Cydonia, uncovering evidence of an intelligent species that existed long before humanity gazed at the stars. They might find traces of a shared ancestry, relics of a civilization that mastered technologies we can scarcely imagine. The journey to Mars is not simply a scientific expedition. It is a voyage into the unknown, a quest to uncover secrets hidden for billions of years, and perhaps to redefine humanity's place in the cosmos. The story of the face on Mars, the whistleblowers who expose secrets, the hackers who breach the most secure networks, and the monumental human missions yet to come all weave together into a tapestry of mystery, curiosity, and relentless exploration. Humanity stands on the threshold of discovery, where the red planet, once silent and distant, may finally reveal its deepest secrets. What lies beneath the surface of Mars remains a question that ignites the imagination, challenges our understanding, and beckons us forward. Perhaps one day, the face on Mars will no longer be a shadowy image in a photograph, but a gateway to understanding the history of life in our solar system and beyond. Until that day arrives, the mysteries endure and the search continues. When we look at the landscapes of planets, moons, and even distant asteroids, we're often struck by shapes and structures that seem almost deliberate, as if they were carved with intention, rather than formed by the slow, patient hands of nature. Some of these formations are immediately recognizable, like towering mountains, deep valleys, and sweeping canyons, which we instinctively understand as products of natural forces such as erosion, tectonic shifts, volcanic activity, and the relentless shaping influence of wind and water over millions of years. Yet, in some places, the lines between natural creation and something seemingly artificial blur in ways that both intrigue and puzzle scientists, explorers, and curious minds alike. One of the most famous examples of this delicate dance between natural explanation and speculation about something more comes from our nearest planetary neighbour, Mars. The region known as Cydonia, located in the northern hemisphere of Mars, has long captured the imagination of those who study the red planet. In the year 1976, NASA's Viking 1 and Viking 2 missions sent back the first detailed images of this region. Among the rocky mesas and jagged terrain, one formation stood out immediately to the human eye. It appeared at first glance to be a colossal human face carved into the Martian surface, with distinct features resembling a nose, eyes, and mouth. To many, the idea that a natural formation could so closely resemble a human face seemed improbable, even absurd. But science is cautious. Geologists, planetary scientists, and skeptics insisted that what the human mind perceives as intentional design is often a trick of perspective, lighting, and the brain's natural tendency to recognize familiar patterns in random objects, a phenomenon known as pareidolia. Pareidolia explains why we often see shapes in clouds, faces on the moon, or familiar figures in rock formations on Earth. When applied to the Martian face, this explanation seemed reasonable at first. Shadows cast by the angle of sunlight across the uneven surface of a mesa could create the illusion of a nose, cheekbones, and a mouth. Yet, as more images arrived from different angles, including photographs taken by other cameras on the Viking orbiters, the structure retained its general facial shape. The mesa appeared in several images to have additional geometric features nearby, resembling pyramids and other angular formations, which further fueled speculation that Cydonia might hold remnants of an ancient civilization, long vanished. Critics and scientists quickly noted that erosion, wind, and dust storms on Mars could produce sharp edges and unusual angles, and that rock formations on Earth often create bizarre and fascinating shapes that seem designed without any intelligent hand behind them. Still, the debate did not end there. In the year 2001, NASA returned to the region with the Mars Global Surveyor, equipped with cameras far more advanced than those on the Viking missions. The images captured were sharper, though curiously, the so-called face appeared more eroded, its features blurred and indistinct. The agency claimed that these new images proved the formation was nothing more than an ordinary rock mesa, shaped by natural processes over millions of years. To the casual observer, this might have seemed conclusive, yet some critics argued that the newer images had been manipulated to obscure details. Whistleblowers and independent analysts claimed that NASA and other space agencies often airbrush anomalies, downplaying or removing evidence that might suggest unusual or artificial formations. One of the most famous cases involved a British hacker named Gary McKinnon, who accessed US military and NASA systems in the early years of the 21st century. McKinnon claimed to have found classified files referencing non-terrestrial officers and unexplained structures on Mars and the Moon, sparking further debate about what might really exist beyond our planet. Looking beyond Cydonia, Mars is filled with geological wonders that straddle the line between the natural and the enigmatic. The planet's surface shows evidence of ancient river valleys, massive volcanoes such as Olympus Mons, the tallest volcano in the entire solar system, and enormous canyon systems like Valles Marineris, which stretches over 4,000 kilometers, a distance longer than the entire width of the continental United States. These natural features demonstrate that Mars, like Earth, has undergone profound geological changes. Water once flowed across its surface, shaping valleys and depositing sediments in what may have been vast lakes or shallow seas. Wind and dust storms continue to reshape the landscape today, slowly but relentlessly eroding surfaces and sculpting features that can appear strikingly symmetrical or oddly familiar to human observers. Yet some formations on Mars and other celestial bodies defy easy classification. In the southern hemisphere, for instance, there are dome-like mounds and terraced plateaus that look eerily regular. Some are arranged in linear patterns or geometric clusters that could be explained as natural erosion or volcanic activity, but the precision of their alignment has led certain researchers to speculate that they may be the remnants of ancient constructions. Similarly, on Earth, we find numerous examples of geological formations that inspire awe and curiosity. The Giant's Causeway in Northern Ireland, with its perfectly hexagonal basalt columns, or the towering sandstone buttes of Monument Valley in the United States, shaped by wind and water over millions of years, look so deliberate that it is easy to imagine they were sculpted by intelligent hands. Yet in these cases, science has provided detailed explanations. Volcanic activity, cooling lava, and differential erosion produced these magnificent structures without any conscious design. The question then arises, how can we distinguish between natural rock formations and potential evidence of intelligent intervention, if such a thing exists at all? Geologists look for several clues: regularity and repetition in patterns, unusual symmetry, and the presence of materials or structures inconsistent with the surrounding environment are all factors that invite closer scrutiny. On Earth, archaeologists can test for artifacts, tool marks, or signs of human or animal activity. On other planets, we rely largely on remote sensing, spectroscopy, and high-resolution imaging to examine surfaces from orbit. If anomalies appear that cannot be explained by known geological processes, scientists consider alternative explanations, though these are often approached cautiously, given the risk of jumping to extraordinary conclusions. Beyond Mars, other planets and moons present similarly puzzling formations. On Saturn's moon, Titan, methane lakes and icy hills form strange landscapes shaped by processes unfamiliar to earthly observers. Europa, one of Jupiter's moons, has a frozen surface crisscrossed with fractures and ridges, suggesting a subsurface ocean and potential geological activity far different from anything on our planet. Even asteroids, like Bennu and Ryugu, display bizarre boulder arrangements and surface features that challenge straightforward geological explanation. While most scientists interpret these as natural results of impact events, gravitational settling and space weathering, some observers wonder whether subtle patterns hint at something more. On Earth, the debate over natural versus artificial formations is also ongoing, though it is easier to study and verify than on distant planets. Ancient civilizations often built monumental structures that mimic or incorporate natural geological features. The pyramids of Egypt, for instance, sit on desert plains, and are aligned with remarkable precision to cardinal points, while Stonehenge in England is arranged to correspond with solstices. Some formations, like the Nazca lines in Peru, take advantage of the natural contours of the landscape to create patterns visible only from above. In each case, it is clear that human intention is involved. But there are other cases, such as the enigmatic terraces of the Bolivian Altiplano or unusual stone circles in the Scottish Highlands, where natural erosion and deposition could easily be mistaken for human activity. This demonstrates the fine line between natural processes and intentional construction, a line that is even more difficult to discern on other worlds. The study of natural rock formations also raises profound questions about the history of life and intelligence in the universe. If Mars, billions of years ago, had water, an atmosphere, magnetic fields, and other conditions conducive to life, it is plausible that some form of civilization could have arisen before catastrophic events rendered the planet largely inhospitable. Massive dust storms, radiation exposure, and the eventual loss of the Martian magnetic field may have destroyed much of the surface evidence. Yet if even fragments of intelligent design remain, whether in geometric mesas, pyramid-like structures, or other anomalies, they could offer tantalizing glimpses of a vanished world. Similarly, examining formations on Earth that seem extraordinary may help us understand how natural processes can create structures that appear deliberate, providing context for interpreting other planetary surfaces. Critics argue that extraordinary claims require extraordinary evidence. The human mind is wired to find meaning and patterns even where none exist. Shadows, angles, and erosion can easily produce forms that suggest faces, pyramids, or architectural features. Yet advocates of the something more hypothesis point to repeated patterns, clustering of geometric features, and unusual arrangements that defy conventional geological explanations. They emphasize the importance of examining multiple images from different angles and lighting conditions, as well as using computer modeling to reconstruct the formation processes. Sophisticated imaging techniques, including 3D mapping and multispectral analysis, allow scientists to test whether a structure is consistent with natural erosion, tectonics, or deposition, or whether it exhibits characteristics that are statistically improbable under known natural processes. The search for understanding is further complicated by the human tendency to assume that our world is the standard for intelligence and design. When we see a shape resembling a human face or a geometric pyramid, our minds instinctively interpret it as evidence of intention, because that is what we are most familiar with. This bias makes it both exciting and dangerous when analysing otherworldly landscapes. We must constantly ask whether we are observing genuine anomalies or simply projecting our expectations onto random formations shaped by billions of years of natural forces. Despite the skepticism, the allure of enigmatic formations persists. They spark imagination, inspire exploration, and challenge the boundaries of scientific investigation. Every new mission to Mars, every probe to the icy moons of Jupiter and Saturn, and every high-resolution image of asteroids or comets adds pieces to the puzzle, sometimes resolving old mysteries, and at other times deepening them. As technology advances, we may discover formations that are undeniably artificial, or we may confirm that nature alone is capable of producing patterns so extraordinary they seem impossible. Either outcome would expand our understanding of the universe, revealing both the power of natural forces and the potential for intelligence to leave traces beyond our planet. Geological explanations for unusual formations are often persuasive. Wind, water, ice, volcanic activity, impacts from meteorites, and tectonic forces have shaped planets for billions of years, producing incredible diversity in landscapes. Yet the mind cannot easily dismiss the possibility of something more. From the moment humans first looked at Mars through telescopes, and later at detailed images returned by orbiters and rovers, the tension between natural and artificial, between randomness and design, has captivated the imagination. It is a tension that forces us to question not only what we see, but how we interpret it. Even on a purely practical level, exploring formations that appear unusual has scientific merit. Investigating anomalies encourages the development of better imaging techniques, more sophisticated models of erosion and planetary geology, and more comprehensive methods of analysis. It sharpens critical thinking, as researchers must weigh the evidence, consider alternative explanations, and guard against cognitive biases. It also inspires public interest in space exploration, geology, and planetary science, fostering curiosity that can lead to future generations of scientists, explorers, and innovators. The pyramids of Cydonia have fascinated scientists, enthusiasts, and conspiracy theorists for decades, igniting heated debates over whether they are products of natural forces or the remnants of an ancient intelligent civilization on Mars. The story begins in the mid-20th century, when humanity first turned its mechanical eyes toward the red planet with a level of detail never before achieved. Mars, the fourth planet from the Sun, has always captivated our imagination, not only because of its reddish hue visible even to the naked eye, but also because of the tantalizing possibility that life might once have existed there. It is a world of extremes, vast deserts, enormous volcanoes, colossal canyons, and polar ice caps that shift with the seasons, creating a planet both eerily familiar and alien in equal measure. In the year 1976, NASA launched the twin Viking missions, Viking 1 and Viking 2, which were designed to orbit Mars and take detailed photographs of its surface. These spacecraft were equipped with high-resolution cameras capable of revealing the smallest details in the Martian landscape, down to a few meters across. When the images returned, scientists around the world were eager to analyze them, looking for geological formations, signs of water, and the possibility of life. It was in this context that the region known as Cydonia came into focus. Cydonia, a vast area located in the northern hemisphere of Mars, is distinguished by its mesas, plateaus, and peculiar hills. Among these features, the Viking images revealed shapes that were unlike anything seen elsewhere on the planet, drawing immediate attention from both scientists and the public. One formation, in particular, sparked worldwide intrigue: a large mesa that bore a striking resemblance to a human face. This, face on Mars as it was soon called, appeared to show eyes, a nose, and a mouth, all aligned with remarkable symmetry. The dimensions of this formation were immense. It stretched over 2 kilometers in length, with the height of its features comparable to the tallest buildings on Earth. When the initial images were analyzed, the play of shadows and light seemed to suggest deliberate construction, as though some intelligent hand had carved a giant visage to gaze upon the surrounding Martian plains. Nearby, other formations added fuel to the mystery. Triangular structures, reminiscent of pyramids on Earth, rose from the Martian soil. These so-called pyramids, or the pyramids of Cydonia, appeared to be arranged in a loose alignment, and some enthusiasts even suggested that they formed geometrical patterns or ley lines similar to those found at ancient sites on Earth. The symmetry, sharp angles, and relative uniformity of these formations led some to speculate that they were not merely natural features created by erosion or wind-blown sediments, but were instead the remnants of an intelligent civilization that had once thrived on Mars. The initial scientific response was cautious. The Viking images, while groundbreaking, were not definitive. Shadows and lighting could play tricks on the human eye, and the phenomenon of pareidolia, the tendency of the mind to recognize familiar shapes in random patterns, was well known. Scientists suggested that these formations might simply be mesas and buttes, shaped over millions of years by Martian winds, dust storms, and other natural geological processes. Mars, after all, has a thin atmosphere, composed mostly of carbon dioxide, which allows dust and sand to move freely, slowly sculpting the surface into shapes that might appear artificial at first glance. Yet, even as skepticism dominated mainstream science, interest in Cydonia grew. Books, documentaries, and conferences explored the possibility that Mars had once hosted a civilization capable of constructing monumental architecture. Authors speculated that the pyramids of Cydonia might predate human history by millions of years, suggesting that an advanced species had risen and fallen on Mars long before humans walked the Earth. Some proposed that a global catastrophe, such as the loss of the planet's magnetic field or massive asteroid impacts, could have wiped out any Martian society, leaving only stone monuments to testify to their existence. In the 1990s, the controversy reignited when NASA launched the Mars Global Surveyor, a spacecraft designed to map Mars with unprecedented accuracy. It returned thousands of images of Cydonia, this time at resolutions far higher than those captured by Viking. To many casual observers, The images appeared to show that the face on Mars was simply a hill, eroded by wind and time, and that the pyramidal structures were merely natural mesas with sharp edges. NASA declared that the formations were the result of ordinary geological processes, emphasizing that lighting conditions and image resolution had initially created the illusion of artificiality. However, this official explanation did not satisfy everyone. Critics argued that the newer images were deliberately altered to obscure anomalies, pointing to inconsistencies in shading and detail. Some whistleblowers claimed that NASA had a pattern of airbrushing, or selectively publishing images to downplay evidence of potential extraterrestrial artifacts. Among those who investigated the matter independently was Gary McKinnon, a British hacker who famously infiltrated NASA systems in the early 2000s, claiming to have discovered hidden files and photographs of unusual structures on Mars. McKinnon and others fueled the belief that the pyramids and the face were part of a broader network of ancient Martian constructions, perhaps even aligned with celestial bodies or energy grids, reminiscent of the sacred geometry observed in human civilizations on Earth. Beyond the photographs, speculation about the pyramids of Cydonia drew upon a wide range of evidence, both scientific and anecdotal. Some researchers examined the topography and noticed that the so-called pyramids seemed unusually regular in shape compared to other Martian landforms. They appeared to have flat bases and triangular sides, often oriented in similar directions, suggesting intentional placement. Others explored geological explanations, noting that volcanic activity, wind erosion, and differential weathering could create sharp angles and apparent alignments, yet these processes rarely produced patterns so geometrically consistent over large areas. Cultural and historical perspectives also entered the discussion. Ancient human civilizations, such as the Egyptians and the Maya, built pyramids that aligned with stars or served as ritual centers. Some theorists suggested that Mars might have hosted a civilization that engaged in similar architectural practices, leaving behind enduring stone structures as a record of their existence. Could it be possible that human knowledge of pyramid building had been influenced by remnants of an earlier Martian culture, passed down across millennia through myth, migration, or even extraterrestrial contact? While speculative, such ideas captured the imagination of writers, artists, and explorers, feeding a narrative that Mars was not merely a barren desert, but a world with a lost history waiting to be uncovered. Scientific investigations also considered the role of erosion and geological time. Mars has experienced dramatic shifts in climate, atmosphere, and possibly magnetic fields over billions of years. During periods when liquid water may have existed on the surface, rivers and floods could have carved valleys and flattened plains, leaving behind mesas and buttes that coincidentally resemble artificial structures. Wind erosion over eons could accentuate sharp angles or create straight lines, while sediment deposition could mimic the appearance of terraces or steps. Some formations, when viewed from specific angles and under particular lighting conditions, might naturally give the impression of geometric precision, a trick of perspective that human brains are especially prone to interpret as deliberate design. In the early 2000s, the European Space Agency and NASA continued to send orbiters and rovers to Mars, each capturing more detailed imagery of Cydonia and other regions. Instruments capable of analyzing mineral composition, surface texture, and even atmospheric interactions provided new insights into the geology of the region. While no definitive evidence of artificial construction emerged, subtle anomalies remained. Certain formations appeared far more regular than surrounding terrain, and some rocks exhibited shapes that seemed unlikely to result purely from natural processes. These peculiarities reignited debates among enthusiasts, scientists, and amateur researchers who argued that the mysteries of Cydonia had yet to be fully explored. The debate over the pyramids of Cydonia is not merely about shapes or images. It taps into fundamental questions about human curiosity, the nature of evidence, and the possibility of a life beyond Earth. Are we predisposed to see patterns and assign meaning where none exists? Or are there genuinely unexplained phenomena on Mars that hint at intelligence? The discussion challenges the limits of science, as it must balance rigorous skepticism with openness to anomalies that defy conventional explanation. Even today, advanced computer modeling and image analysis techniques are applied to the Cydonia region, testing hypotheses about lighting, perspective, and erosion to determine whether the formations are purely natural or if a more extraordinary explanation is plausible. public fascination has remained constant over decades. The face on Mars and the pyramids of Cydonia have inspired documentaries, feature films, novels, and countless internet forums. They represent not only the mystery of Mars, but also humanity's enduring desire to connect with other intelligences, to find evidence that we're not alone in the cosmos. The pyramids and the face, whether natural or artificial, serve as symbols of curiosity, imagination, and the eternal quest for understanding. For every skeptic who insists they are simply mesas, there is an enthusiast who sees the unmistakable signature of intelligence, perhaps the legacy of a civilization lost to time and catastrophe. It is important to remember that Mars itself is a planet of extremes, with conditions that challenge our understanding of geology and climatology. Surface temperatures fluctuate wildly, from as low as -120 degrees Celsius at the poles during winter to highs of 20 degrees Celsius near the equator in summer. Massive dust storms can envelop the entire planet for months, reshaping the terrain and concealing or revealing features over time. The thin atmosphere and low gravity, about 38% of Earth's, influence erosion differently than on our planet. These factors create a complex environment where natural formations can take on unusual shapes, sometimes defying straightforward explanation. Despite decades of study, the question remains unresolved. No Mars mission has yet provided conclusive proof of artificial structures, yet neither has any explanation completely accounted for the peculiar geometry and alignment of certain formations in Cydonia. This enduring mystery exemplifies the tension between conventional science, which seeks empirical evidence and reproducible results, and human imagination, which finds wonder and possibility in patterns and anomalies. Whether the pyramids of Cydonia are the result of wind, erosion, and chance, or the remnants of a lost Martian civilization, they continue to provoke thought, debate, and exploration. The allure of Cydonia lies not only in the formations themselves, but also in what they represent. The idea that Mars, a neighbouring world, might have a story of its own, hidden beneath dust, rock, and the passage of time. As humanity advances technologically, with spacecraft capable of landing with unprecedented precision, drilling beneath the surface and even returning samples to Earth, the potential for new discoveries grows. Each mission brings us closer to answering the fundamental question: are the pyramids of Cydonia merely natural landforms, or do they hold the echoes of an intelligent past, a civilization that once walked the Martian plains and left behind stones as silent witnesses to its existence? When we first gaze at the surface of Mars, it often seems like a vast, barren, reddish desert, filled with craters, dust storms, and endless stretches of rocky terrain. But within the northern hemisphere of this dry and desolate planet lies a region that has fascinated scientists, explorers, and dreamers for decades: Cydonia. This area, with its strange, often sharply defined features, has ignited debates, inspired theories, and captured the imagination of anyone who's ever looked up at the night sky and wondered if we are alone. Among its most famous features is the enigmatic face on Mars, a formation that looks startlingly like a human face staring up at the heavens. Surrounding this peculiar visage are a number of structures that seem to defy simple geological explanation. Pyramidal forms that rise from the Martian plain with unusually straight edges, symmetrical angles, and patterns that appear almost deliberate. Taken together, the symmetry and geometry of these structures invite us to question whether they are purely the products of nature, or whether they hint at something more mysterious, perhaps even the traces of an ancient civilization lost to time. The face on Mars, first brought to public attention by the images taken by the Viking 1 orbiter in the late 1970s, immediately stood out because of its striking resemblance to a human face. Seen from a certain angle, under particular lighting conditions, the formation exhibits features that we instinctively recognize: eye sockets, a nose, lips, and a jawline. To those who first saw it, it seemed uncanny, almost too deliberate to be a mere coincidence. While the initial images were somewhat low in resolution and shadowed in ways that enhanced the appearance of facial features, the impression of symmetry was undeniable. The face appeared to have balanced proportions. The eyes were set evenly apart, the nose fell roughly in the centre, and the chin line seemed to mirror the general shape of a human face. From a geometric perspective, This is remarkable because symmetrical patterns are rare in purely natural formations, especially at such a scale. On Earth, erosion, sedimentation, and tectonic activity tend to produce irregular forms, so encountering something with such regularity immediately triggers our pattern-seeking minds. Beyond the face itself, the surrounding terrain of Cydonia adds layers of intrigue. Several pyramidal structures, some appearing almost perfectly triangular from aerial views, are scattered around the plains. These formations have straight edges, sharp apexes, and flat sides, resembling the pyramids built by humans in ancient Egypt or Mesoamerica. Some researchers have even noted that certain alignments and orientations of these pyramids suggest a non-random pattern, as if they were arranged with deliberate intent. The way the shadows fall along the edges during the Martian day accentuates their straight lines, giving the impression that they have been sculpted rather than eroded. Measurements made from orbital imagery indicate that some of these structures maintain angles close to 90 degrees at the base and display near equilateral proportions, suggesting a geometry that, in human experience, is usually the product of design rather than chance. The idea that symmetry itself can be meaningful is important. Symmetry is a universal principle in nature. It appears in snowflakes, crystals, flowers, and even the wings of butterflies. Yet, in most natural processes, symmetry is often imperfect. Random geological forces, wind erosion, meteorite impacts, lava flows, and volcanic activity produce shapes that are irregular, jagged, or uneven. The human eye, however, is extremely sensitive to symmetry, especially when it manifests on a scale that seems proportionate to human experience. In the case of Cydonia, the combination of the face on Mars and nearby pyramidal formations presents a rare scenario. Multiple features that individually could be explained as natural anomalies, but collectively exhibit a pattern of symmetry that stretches across kilometers of Martian plains. This combination invites speculation. Was this merely a coincidence, or is there a possibility that some intelligence, long vanished, once influenced the landscape of Mars? Adding to the mystery is the way these structures interact with one another. Certain pyramids appear to be aligned in straight lines or grid-like patterns. From aerial imagery, some formations seem to point toward the face or towards each other, as if part of a larger, cohesive layout. Geometrically, these alignments are striking because the distances and angles involved are precise enough to catch the attention of scientists familiar with spatial planning. On Earth, we often see such alignments in the architecture of ancient civilizations: roads, temples, and monuments carefully arranged to align with celestial events, cardinal directions, or each other. On Mars, however, no known civilization has left confirmed evidence, so the presence of straight lines and aligned structures raises deep questions about the planet's history. Even if wind and erosion played a role in shaping the land, the probability that multiple formations across a broad area coincidentally align with such precision is statistically low, making Cydonia a captivating puzzle. The study of geometry and symmetry in Cydonia also invites comparisons with fractal patterns. Fractals are self-repeating shapes found in nature. River networks, mountain ranges, and coastlines often exhibit similar forms on different scales. Some analysts have suggested that Martian formations display fractal qualities, where smaller pyramidal shapes echo the dimensions or angles of larger structures nearby. While fractal geometry can occur naturally, the specific repetition of angular forms alongside the human-like symmetry of the face remains unusual. This combination of features prompts researchers to consider the possibility of both natural and artificial influences. Could wind, water, and geological activity alone produce such a complex arrangement, or is there an underlying principle, perhaps long lost, that explains why these patterns exist? Lighting and perspective play a crucial role in how symmetry and geometry are perceived in Cydonia. The original Viking images, taken in 1976 and 1977, were captured at a specific time of day when shadows stretched across the plains, emphasizing edges and contours. Under different lighting conditions, some features appeared less distinct, causing the face to look blurred or the pyramids to lose their sharp outlines. Later missions, including the Mars Global Surveyor in 2001 and the Mars Reconnaissance Orbiter in 2006, provided higher resolution images. Some of these newer images showed more erosion and weathering, while others revealed new angles that preserved the sense of geometric order. This variability highlights an important principle. Perception of symmetry depends not only on the object itself, but also on how light interacts with it, how our eyes interpret shadows, and how images are processed. The human tendency to recognize familiar patterns, especially faces, a phenomenon known as pareidolia, means that our brains may accentuate features that appear symmetrical, even when they are imperfect. Despite the possibility of optical illusion, the mathematics of the structures cannot be ignored. Researchers who have analysed Cydonia using digital elevation models and three-dimensional reconstructions note that some angles are consistently close to multiples of 30 or 45 degrees, measurements that are unusually precise for natural erosion. Some formations display bilateral symmetry, where one side mirrors the other with remarkable fidelity. Others exhibit triangular proportions or rectangular layouts that maintain uniformity across hundreds of meters. Even if some of these properties could arise from wind patterns or tectonic activity, the sheer number of symmetrical and geometric forms raises the question of whether nature alone can account for everything observed. It is this layering of features, faces, pyramids, aligned structures, and repeated angles that makes Cydonia a region unlike any other on Mars. The cultural resonance of symmetry and geometry cannot be overlooked. On Earth, humans have long associated geometric precision with intelligence and intentionality. Ancient architects, mathematicians, and astronomers used symmetry and proportion to express beauty, order, and cosmic harmony. The pyramids of Egypt, the temples of Greece, and the stone circles of Britain all demonstrate a deep appreciation for geometric relationships. When we see similar features on Mars, even if they were created naturally, our minds instinctively ask why. Are these patterns simply coincidences, or could they be the echoes of a lost civilization that once walked Mars, leaving behind carefully arranged monuments, perhaps intended to endure across the eons? The broader scientific debate surrounding Cydonia reflects this tension between natural and artificial explanations. Mainstream geologists often argue that the face on Mars is a mesa shaped by wind, dust, and minor erosion, while pyramidal structures result from fractured bedrock and differential erosion. From this perspective, any perceived symmetry is coincidental, and our brains are wired to recognize patterns where none were deliberately created. Alternative researchers, however, point to the concentration of geometric features, alignments, and repeated angles as evidence that something more deliberate may have occurred. They argue that natural forces alone are insufficient to produce the apparent order and precision found across the region. The truth may lie somewhere between these extremes, with some formations shaped by nature, others enhanced by human-like pattern recognition, and still others perhaps influenced by unknown processes. Another element to consider is the scale of these structures. The face on Mars spans approximately 2,100 meters from one end to the other, while the pyramidal formations vary, with some reaching several hundred meters in height. At these scales, maintaining precise geometry is extremely difficult for natural forces alone. Wind erosion, for example, tends to create rounded edges rather than sharp corners, while thermal expansion and contraction produce cracks that follow less predictable paths. The presence of multiple features with sharp angles, consistent proportions, and alignment over a large area challenges conventional geological explanations. It is this combination of scale, geometry, and symmetry that makes Cydonia stand out in the Martian landscape and continues to inspire both scientific inquiry and imaginative speculation. The role of modern technology in analysing Cydonia cannot be overstated. High-resolution cameras, laser altimetry, and digital modelling have allowed scientists to examine these features in unprecedented detail. Three-dimensional reconstructions enable the study of angles, shadows, and surface textures in ways that were impossible during the Viking missions. Even more advanced tools such as spectral analysis and radar mapping help determine the composition and internal structure of the formations. While these tools do not provide definitive proof of artificiality, they allow for meticulous measurement of symmetry, geometry, and spatial relationships, revealing patterns that might otherwise go unnoticed. Each new dataset fuels the debate, providing additional evidence that can be interpreted in multiple ways depending on one's perspective. In addition to scientific studies, public fascination has played a significant role in keeping the mystery alive. Popular books, documentaries, and internet forums have explored Cydonia's features, often presenting the symmetry and geometry of the landscape as evidence of intelligent design. This widespread interest has led to a cultural feedback loop, where public imagination informs scientific discussion, and vice versa. Even skeptics acknowledge that Cydonia represents a unique and intriguing anomaly in the solar system, worthy of attention and careful study. The interplay between observation, interpretation, and imagination highlights the human desire to find meaning in the universe and to see patterns that connect us to other possible intelligences. It is important to acknowledge that our understanding of Cydonia is still evolving. As new missions arrive on Mars, bringing more advanced imaging systems and potentially even robotic explorers capable of close-up study, we may gain further insight into these enigmatic structures. Whether the symmetry and geometry of Cydonia result entirely from natural processes, from optical illusions, or from a lost Martian intelligence, the region continues to challenge our assumptions and stretch the boundaries of our imagination. It invites us to consider the interplay of nature and perception, the possibility of ancient civilizations beyond Earth, and the enduring power of geometry as a language that transcends worlds. When we look up at Mars through a telescope, or when we examine the countless images sent back by orbiters and rovers over the decades, we are immediately struck by a world that is both familiar and alien, a landscape that echoes deserts on Earth, yet carries its own strange signature. Mars is a planet bathed in light and shadow, its terrain sculpted by ancient forces and modern illusions alike. Mountains, valleys, canyons, and plateaus stretch across its surface, casting shadows that shift with the slow march of the Martian day. Yet within these shadows, our eyes, and sometimes our minds, play tricks on us. Optical illusions emerge, coaxing ordinary rock formations into shapes that suggest faces, pyramids, or monumental ruins, stirring the imagination and fueling debate across decades. The interplay of shadows and light on Mars is not merely a matter of photography. It is a complex dance shaped by the sun, the planet's thin atmosphere, dust storms, topography, and even the quirks of human perception. Mars receives less sunlight than Earth, roughly 43% of the intensity we experience on our own planet, because it orbits nearly 1.5 times farther from the Sun. This means that sunlight strikes its surface at a weaker angle, creating longer shadows that exaggerate the relief of its terrain. When sunlight falls across a crater or ridge, the effect can be dramatic. A slight indentation in the rock may appear to be a deep chasm, and a modest rise may take on the appearance of a towering pyramid. The planet's thin atmosphere, composed mostly of carbon dioxide with traces of nitrogen and argon, does little to scatter light, leaving sharp, crisp contrasts between illuminated and shaded areas. On Earth, atmospheric scattering softens these contrasts, but on Mars, they remain stark, sometimes bordering on surreal. Photographs taken from orbit reveal ridges that seem impossibly sharp, and valleys that appear to plunge straight down into darkness, even when we know that the actual slopes are gentler. This natural exaggeration plays directly into the human mind's penchant for seeing familiar patterns, a phenomenon psychologists call pareidolia, our tendency to perceive meaningful shapes, like faces or objects in random configurations. The phenomenon of pareidolia is especially evident in the famous Martian feature known as the face on Mars, located in a region called Cydonia. When the Viking 1 orbiter captured its first image in 1976, the feature appeared unmistakably humanoid. A broad forehead, deep-set eyes, a prominent nose, and a firm, closed mouth. Initial reactions range from excitement to skepticism. Scientists quickly noted that the resolution of the Viking images was limited, and shadows across the plateau created the illusion of facial features. Yet the image captured the public imagination in ways that no dry geological explanation could rival. Over the following decades, multiple missions returned to Cydonia, with higher resolution cameras, revealing the so-called face as a naturally eroded mesa. Shadows still played tricks though, and some observers continued to argue that subtle alignments suggested more than mere coincidence. Whether artificial or natural, the face on Mars is a perfect illustration of how shadows, light, and human perception intertwine to create compelling illusions. The The effect of light and shadow on Mars is further complicated by the planet's unique dust environment. Mars is famous for its planet-wide dust storms, which can envelop the surface in a reddish haze for weeks at a time. These storms scatter sunlight in complex ways, softening some shadows while intensifying others, depending on the angle and density of the airborne particles. Fine dust settling on rocks and ridges can alter the reflectivity of the surface, creating bright highlights where none existed before, or dark patches that make flat areas appear sculpted. This dynamic environment means that photographs of the same location, taken weeks or months apart, can look dramatically different. A mound that appeared perfectly smooth in one image might, under different lighting conditions, seem jagged or folded, giving the impression of structures or unnatural formations where none exist. This is a phenomenon that planetary scientists must carefully account for when interpreting imagery, but it also opens the door for speculation and wonder among those fascinated by the possibility of hidden Martian architecture. Beyond the face, Cydonia and other Martian regions are scattered with geometric formations that spark the imagination. Pyramid-like shapes, sharply angled ridges, and triangular mesas appear across the landscape. Some of these features are undeniably natural, formed by wind erosion, freeze-thaw cycles, and the slow, patient work of ancient water flows. Yet the angle of sunlight can exaggerate their geometry, producing optical illusions that suggest symmetry and order. A simple triangular mound, under the right lighting, can appear to be a near-perfect pyramid, casting a shadow that makes its sides look smooth and intentionally constructed. The interplay of topography and illumination can also create the illusion of straight lines where none exist, making craters align or ridges converge in ways that seem deliberately arranged. These optical effects remind us that the Martian surface is not merely a passive landscape, but an active canvas upon which light paints shifting, sometimes deceptive patterns. Optical illusions on Mars are not limited to large-scale features. Smaller-scale textures, cracks in rock, streaks of dust, and ripple patterns in sand dunes can interact with light in unexpected ways. When sunlight strikes a sand dune at a low angle, it accentuates the crests and troughs, making them appear sharper and deeper than they are. Tiny pits in rock faces can cast shadows that resemble eyes, mouths, or even inscriptions, depending on the viewer's perspective. Rover missions, such as Spirit, Opportunity, and Curiosity, have returned countless images of such surfaces, revealing landscapes that are both familiar in texture and surreal in composition. In some cases, the human brain superimposes patterns or symbols onto these natural features, generating visions of hieroglyphs, animal shapes, or miniature figurines. These effects are amplified when we view images on screens or in print, where contrast and brightness can be adjusted to heighten the illusion. Mars also experiences dramatic changes in lighting throughout its day, which further influences perception. The Martian day, known as a sol, lasts approximately 24 hours and 39 minutes, nearly mirroring Earth's rotation. As the sun moves across the sky, shadows lengthen, shorten, and shift direction, altering how terrain is perceived. A flat plain can suddenly appear to host ridges or depressions as shadows sweep across it. This daily metamorphosis has led to numerous reports of vanishing or appearing structures, where features seem to emerge or disappear simply due to changes in illumination. Observers must exercise caution when interpreting single images, as the position of the sun can dramatically affect perception, turning mundane geological formations into startling visual spectacles. The angle of sunlight also plays a critical role in the apparent alignment of features. Some observers have noted that ridges, mounds, and mesas in regions like Cydonia or Arabia Terra appear to form geometric patterns when viewed under specific lighting conditions. While these alignments are largely natural, created by the interplay of wind, water, and tectonic stress, the human mind often interprets them as evidence of design. Straight lines and sharp angles are rare in nature, and when we perceive them, even faintly, we instinctively consider the possibility of intentional construction. This is why many enthusiasts remain fascinated by Mars, seeing in its shadows and light the faint echoes of an ancient intelligence. Another intriguing optical effect arises from the Martian atmosphere itself. Unlike Earth, where clouds scatter sunlight broadly, Mars' thin clouds and dust can create localized halos, diffused glows, and subtle color variations. These atmospheric phenomena can highlight certain features while masking others, creating the illusion of depth, height, or texture that is not physically present. For instance, the faint reddish glow of a Martian sunrise can elongate shadows across a crater floor, making it appear deeper, while a thin haze can smooth jagged rocks into shapes that resemble sculptures. These effects combine with surface lighting to produce illusions that persist, even under careful scientific scrutiny. In addition to natural optical illusions, the technology used to capture images of Mars introduces its own distortions. Cameras aboard orbiters and rovers have varying resolutions, lens characteristics, and exposure settings. High-resolution images can reveal extraordinary detail, but they can also exaggerate edges and textures, creating artifacts that look like structures or patterns. Lower-resolution images, such as those taken during the early Viking missions, can blur features together, forming composite shapes that the mind interprets as familiar objects. Image processing techniques, contrast enhancement, color adjustment, and sharpening, while useful for scientific analysis, can unintentionally amplify these illusions. This interplay of light, terrain, and human technology creates a landscape where reality and perception constantly intertwine. The perception of shadows and light on Mars is also influenced by the planet's seasons. Mars has a tilt similar to Earth's, about 25 degrees, which gives it seasonal variations. During the northern summer, the sun arcs higher in the sky, casting shorter shadows, while in winter, the sun stays low, stretching shadows across vast plains. These seasonal differences can make the same formation look radically different at different times of the year. A mesa that appears flat and unremarkable in one season may, under low winter light, reveal deep ridges and angular slopes, inviting speculation about artificial structures. Dust accumulation during certain seasons can further enhance these effects, darkening depressions and brightening elevated surfaces, creating a constantly evolving play of light and shadow. In considering shadows and optical illusions on Mars, we must also acknowledge the human element, expectation, and imagination. When scientists, hobbyists, and the public examine Martian images, they bring prior knowledge, cultural symbols, and subconscious biases to the interpretation. This psychological overlay amplifies the impact of optical illusions. A randomly eroded rock may be dismissed as insignificant by one observer, yet perceived as a monumental statue by another. The history of human fascination with ancient civilizations and monumental architecture predisposes us to see pyramids, temples, and faces in even the most ordinary Martian terrain. Shadows and light merely provide the stage upon which our minds project these narratives, giving rise to stories, debates, and even conspiracy theories about ancient Martian intelligence. Despite the strong influence of optical illusions, studying shadows on Mars is scientifically valuable. By analysing how shadows fall across craters, dunes, and ridges, scientists can estimate the height and slope of terrain features, determine surface roughness, and model how dust and sand accumulate. Shadow measurements from multiple angles help reconstruct three-dimensional models of Martian landscapes, revealing geological history and processes that shaped the planet over billions of years. This practical application of light and shadow highlights the duality of their role. They can mislead casual observers while providing crucial insights to careful researchers. Shadows and light also affect thermal properties on Mars. Sunlit surfaces warm during the day, while shaded areas remain cold, influencing wind patterns, dust lifting, and even the behavior of frost and ice. These temperature differences can subtly change the appearance of terrain over time. Frost may cling to depressions while exposed ridges remain bare, creating transient optical contrasts that trick the eye into seeing patterns and shapes. Even fleeting shadows cast by passing clouds or dust devils can momentarily alter the landscape, generating temporary illusions of movement or structure. When we combine all these factors, topography, sun angle, atmospheric effects, dust, seasons, and human perception, the Martian surface becomes a constantly shifting theatre of optical phenomena. Peaks rise or sink depending on the hour, craters deepen or flatten, and mesas transform into faces or pyramids. Mars is a planet of mutable perception, where the border between reality and illusion is often ambiguous. This is why features like the face on Mars, the Cydonia pyramids, and countless other geometric formations continue to spark debate. They remind us that observing a planet is not a purely objective act. It is an interplay between physical reality, light, and the interpretive machinery of the human brain. The fascination with shadows and light on Mars also touches on deeper questions about the possibility of life, intelligence, and history beyond Earth. If natural processes can produce structures that appear meaningful, might there also be deliberate structures hidden among them? Conversely, the study of these illusions teaches humility. Our brains are wired to find patterns, sometimes where none exist. Distinguishing between natural geometry and potential evidence of intelligence requires careful measurement, repeated observation, and a recognition of the many ways light and shadow can deceive. Even today, as orbiters like Mars Reconnaissance Orbiter and rovers like Perseverance capture increasingly detailed images, the interplay of light, shadows, and optical illusions remains a central concern. High-resolution imaging has clarified many earlier mysteries, yet it has also revealed new subtleties. Tiny ridges can mimic roads or walls, dust streaks can resemble inscriptions, layered rock can suggest terraces or pyramids. Every new photograph must be interpreted in light of these effects, and each shadow is a reminder that perception is never neutral. Mars challenges us to see with both wonder and skepticism, to appreciate the beauty of illusions while seeking the truth behind them. When we gaze across the rust-coloured plains of Mars, particularly the region known as Cydonia, we are often struck by a strange and compelling sense of familiarity, as if the planet is holding up a mirror to human history. Cydonia, a region located in the northern hemisphere of Mars, has long fascinated astronomers, planetary scientists, and even casual observers alike, not merely for its desert-like beauty, but for the puzzling formations that appear to rise from its dusty surface. Chief among these features is what has popularly come to be called the face on Mars, a formation that, from certain angles and under particular lighting, seems to bear the unmistakable appearance of a human face. Yet surrounding this enigmatic visage are numerous other geometric structures, pyramids, mesa-like formations, and unusually straight-edged constructs that, in their proportions and arrangement, seem almost deliberate, as though shaped with intent rather than formed by random erosion and wind. When we begin to compare these features with ancient monuments on Earth, the parallels become surprisingly intriguing. Consider the pyramids of Egypt, constructed thousands of years ago in the deserts of Giza, along the west bank of the Nile. The Great Pyramid of Khufu, which alone measures approximately 466 feet in height and covers 13 acres at its base, is a testament to human ingenuity and planning. Its sides are precisely aligned with the cardinal points of the compass, a feat of astronomical and architectural sophistication that has puzzled historians and engineers alike. The smaller pyramids of Khafra and Menkaure nearby echo the same geometric exactness, creating a sense of ordered harmony across the landscape. Now, when we turn our gaze to Cydonia, we find formations that, although natural in their raw material, exhibit similarly straight lines, sharp angles, and a geometric coherence that defies the usual randomness of erosion or geological activity. One pyramid-shaped mound, often referred to by researchers as the D&M pyramid, rises from the Martian surface with edges and a slope reminiscent of the pyramids of Giza. Its angularity is such that some observers have speculated it might not be a natural formation at all, but rather an ancient monument, carefully constructed by a civilization now lost to time and perhaps to the universe itself. Further comparisons emerge when we examine the layout of these structures. The pyramids in Egypt were not haphazardly placed. They followed precise alignments relative to one another and to celestial bodies, a practice also evident in other ancient civilizations. In Mesoamerica, for example, the pyramids of Teotihuacan, constructed over 2,500 years ago, were carefully aligned along a central avenue that mirrors the movements of the sun. The Pyramid of the Sun, rising over 220 feet tall, and the Pyramid of the Moon, positioned along the same axis, create an architectural narrative that binds the urban layout to cosmic cycles. In Cydonia, when the spatial relationships between the pyramidal formations are analysed, a similar attention to alignment becomes apparent. The edges of certain pyramids seem to form parallel lines that point towards specific features on the Martian surface, while other formations appear to occupy precise distances from one another, suggesting that their arrangement may not be random. Just as ancient humans on Earth sought to anchor their sacred spaces in harmony with the stars, so too might these Martian features hint at a civilization attuned to celestial rhythms, leaving clues for observers to decipher across eons. Another striking similarity between Cydonia and ancient Earth monuments lies in the sense of symmetry. Human constructions, especially those intended for ritual, religious, or commemorative purposes, often display careful symmetry. The temples of Angkor Wat in Cambodia, built in the early 12th century, exemplify this principle, with perfectly balanced corridors, reflective pools, and symmetrical towers that echo one another across the temple complex. The same can be said for Stonehenge in England, a prehistoric monument constructed roughly 4,500 years ago, whose arrangement of massive stones follows a deliberate circular symmetry aligned with solstices and celestial events. In Cydonia, the so-called face and the surrounding pyramids also seem to respect a form of symmetry. The face itself, while eroded and weathered by billions of years of wind and dust, retains proportions reminiscent of human faces, with features roughly aligned along a vertical axis. Nearby pyramidal mounds, when measured and mapped, reveal repeating patterns and similar slopes, suggesting that the creators of these formations may have intentionally mirrored shapes to create visual harmony. This repetition of form, this echoing of angles and proportions, is one of the hallmarks of human architecture on Earth, and its presence on Mars cannot help but invite speculation about intelligence behind the designs. Beyond symmetry and geometric precision, the scale of Cydonia's features also invites comparison with ancient Earth monuments. The Great Pyramid of Khufu, as previously mentioned, reaches almost 500 feet in height, yet the pyramids of Cydonia rise to comparable scales when their dimensions are calculated relative to the Martian terrain. One of the larger pyramids measures approximately 330 feet from base to apex, a height that, while not exact, is strikingly reminiscent of human-built pyramids on Earth. The mesa formations, which some observers have likened to eroded ziggurats or step pyramids, also exhibit layered structures similar to those constructed by ancient Mesopotamians. The ziggurats, such as the Great Ziggurat of Ur built around 2100 BCE, were massive stepped edifices reaching nearly 150 feet in height, composed of successive terraces that narrowed toward the top. The layering of Martian mesas, with flat plateaus and steep sides, evokes the same principle, a stacking of geometric forms to create a monumental presence, visible across the surrounding landscape. Materials and texture provide another avenue for comparison. Ancient Earth monuments were often built with enduring stone, chosen for its durability and resistance to erosion. Egyptian builders quarried limestone and granite. The Mesoamerican civilizations carved volcanic rock and limestone, and Mesopotamian architects baked mud bricks in the sun. On Mars, the stone is naturally occurring rock and sediment shaped by both environmental and perhaps artificial means. While erosion and weathering have undeniably shaped the surfaces, smoothing corners and rounding edges, some faces of the Martian pyramids retain unusually sharp angles and planar surfaces, as though crafted with an intent to resist the relentless forces of Martian wind and dust storms. These textures, combined with the regularity of form, contribute to the sense that these are not merely accidental shapes, but structures with purpose, much like the carefully chosen materials and precise construction methods employed by humans on Earth. The way Cydonia's structures interact with light and shadow further strengthens the comparison. Ancient builders were keenly aware of the visual effects of sunlight on their monuments. In Egypt, the slanting rays of the sun at sunrise and sunset illuminate the pyramids in dramatic fashion, creating long shadows that accentuate their geometric perfection. Similarly, the temple complexes of the Maya and Aztecs were designed so that the sun's position would highlight key features during solstices and equinoxes. On Mars, the position of the sun, combined with the thin Martian atmosphere, casts shadows across Cydonia that accentuate the angularity and the facial features of the formations. Observers have noted that at certain times of the Martian day, the face seems to gaze outward, with deep shadows filling what appear to be eyes, and pyramids casting long, straight-edged shadows across the plains. This interplay of light and form is remarkably reminiscent of human architectural intentions, in which the designer sought to control perception, to make shapes appear monumental and imposing through the careful manipulation of natural illumination. Moreover, The arrangement of Cydonia's structures relative to their surroundings invites comparison with ancient Earth monuments situated in complex landscapes. The Egyptians often built near the Nile, a lifeline that provided not only resources, but also a sense of cosmic and cultural orientation. The ziggurats of Mesopotamia rose above the surrounding flatlands, creating visual and spiritual focal points within cities. Similarly, the pyramids and mesa-like formations of Cydonia are not randomly scattered across the Martian surface. Certain clusters of pyramids appear to form lines pointing toward the face, while others occupy positions that suggest an awareness of the broader Martian topography. The spatial relationships evoke the same kind of purposeful placement that characterized human monuments on Earth, reinforcing the sense that Cydonia was not merely a natural landscape, but potentially a canvas for intelligent design. The erosion and weathering patterns also mirror human attempts to preserve monumental form. On Earth, ancient builders often designed with longevity in mind, understanding that wind, rain, and time would gradually wear away exposed surfaces. The pyramids, ziggurats, and temples were built from massive blocks, angled or layered to withstand centuries of natural wear. On Mars, billions of years of wind-blown dust, temperature extremes, and minor seismic activity have weathered the surfaces of the face and pyramids, yet the underlying forms persist. This persistence is notable because natural erosion tends to produce irregular, chaotic shapes, not the angular, planar structures seen in Cydonia. The fact that the Martian features retain their general form suggests either remarkable resilience, or more intriguingly, intentional design that anticipated long-term preservation, much as ancient humans meticulously engineered their monuments to endure time. In addition, the human propensity for symbolic representation finds echoes in Cydonia. Many Earth monuments carry symbolic or ritual significance. The Sphinx in Egypt guards the pyramids with a composite form of human and lion, symbolizing strength and wisdom. The stepped ziggurats are believed to have been stairways to the heavens, connecting mortals with divine realms. Stonehenge aligns with solstices to mark celestial cycles. The face on Mars itself evokes the possibility of symbolic representation, resembling a humanoid visage in a way that naturally draws attention, fosters identification, and inspires speculation. Whether this resemblance is intentional or coincidental, the presence of facial features, along with surrounding pyramidal forms, creates a tableau that humans instinctively interpret as meaningful, echoing our own tendency to imbue structures with spiritual or cultural significance. Finally, one cannot ignore the subtle yet powerful psychological resonance that both Cydonia and Earth's monuments provoke. Standing before the pyramids of Giza, one feels a sense of scale, history, and mystery that transcends the physical forms. The ziggurats of Mesopotamia, the temples of Mesoamerica, the Sphinx and the great statues of Easter Island all evoke wonder, prompting questions about the civilizations that created them. In Cydonia, this psychological effect is mirrored. Even through the grainy images captured by orbiters and the thin light filtered through the Martian atmosphere, the face and surrounding pyramids provoke a similar sense of awe. They suggest a story, a civilization, a purpose that has long vanished but left enduring traces. This emotional and cognitive response is strikingly similar to the human experience of encountering monumental architecture on Earth, further reinforcing the comparison between Martian features and ancient terrestrial constructions. NASA's official statements regarding the region known as Cydonia on Mars have consistently reflected a cautious and scientific perspective. Since the first images from the Viking mission in the mid-1970s, Cydonia has been a subject of interest not because of any confirmed artificial structures, but because of its unusual terrain and shapes that sparked public curiosity. In 1976, the Viking orbiter cameras sent back images of the Martian surface, and among these images was a formation that some interpreted as resembling a humanoid face. NASA's scientists approached this observation with a combination of curiosity and skepticism. They emphasized that the appearance of a face could be explained by natural geological processes and the way sunlight and shadows interacted with the terrain at the time the photographs were taken. From the beginning, NASA maintained that the so-called face on Mars was a product of pareidolia, a psychological phenomenon in which the human brain interprets random patterns as familiar shapes, particularly faces. In the late 1970s, after the Viking images became publicly available, NASA researchers pointed out that the resolution of the images was relatively low by modern standards. The shadows and angles of the ridges and valleys created an impression of a facial structure, yet there was no scientific evidence to suggest that any intelligent design was involved. Scientists explained that wind erosion, volcanic activity, and other natural forces could sculpt rocks into shapes that might appear artificial when viewed from certain perspectives. Throughout the late 1970s and early 1980s, NASA repeatedly stated in public reports and press briefings that the Cydonia formations were natural. In 1976, after receiving inquiries from the public and media, NASA officials emphasized that the Viking orbiter mission had not been designed to search for artificial structures. Its cameras were intended to study the planet's surface features, measure atmospheric conditions, and gather data about Mars' geological history. Any interpretations beyond these goals were considered speculative and outside the scope of the mission. NASA also clarified that the initial images showed only a small portion of the region, and that the apparent face could change in appearance under different lighting and viewing angles. The years following the Viking mission saw sporadic interest from both scientists and the general public. NASA maintained that further investigation was necessary to understand the features of Cydonia in a scientific context. In the 1990s, with the advancement of technology and the launch of new Mars missions, NASA continued to affirm that the face on Mars and surrounding structures did not provide evidence of extraterrestrial construction. The Mars Global Surveyor, which arrived at Mars in 1997, offered higher resolution images of the Cydonia region. These images revealed more detail, showing that the facial appearance seen in the Viking photographs was largely a trick of shadow and light on natural mesa formations. NASA scientists published these findings in official mission reports and emphasized that the higher resolution images supported the original interpretation that these formations were natural. NASA's public communications consistently highlighted the difference between photographic illusions and scientific evidence. The agency explained that Mars is a planet with a long history of erosion, wind-driven sand movement and tectonic activity, all of which can create unusual formations. The Cydonia region, in particular, contains mesas, valleys, and plateaus, which are common geological features across Mars. NASA researchers pointed out that the size of the formations, often hundreds of meters across, could be misleading when viewed from the Viking orbiter's distance. Shadows could exaggerate ridges, slopes, and depressions, creating the illusion of symmetry or familiar patterns. In official statements, NASA addressed public fascination and the rise of conspiracy theories. Agency spokespeople acknowledged that the media and popular culture had amplified the idea that the formations could be artificial. NASA emphasized that while imagination and curiosity are valuable human traits, scientific conclusions must be based on verifiable evidence. In 1997, for example, when the Mars Global Surveyor captured sharper images, NASA issued press releases clarifying that the facial appearance had disappeared in these higher resolution views, reinforcing the interpretation that the original face was a coincidental arrangement of natural landforms. NASA also made a point to describe the scientific process used to analyze the Cydonia region. Researchers applied photogrammetry, a technique that uses multiple images to reconstruct three-dimensional shapes to determine the true contours of the mesas and valleys. The three-dimensional models demonstrated that the features lacked the symmetry, proportion, and regularity that would suggest artificial construction. While some individual ridges or angles could appear straight or angular, these were typical of sedimentary layering and erosion patterns found in terrestrial analogues on Earth. Official reports repeatedly emphasized that no evidence of artificial structures, roads, or buildings had been detected. Over the years, NASA continued to respond to inquiries from the public, media, and academic community. Press briefings, conference presentations, and mission updates consistently presented the same conclusions. The Cydonia formations are natural, formed by the interplay of geological processes and lighting conditions. NASA also stressed that scientific understanding evolves with technology. But as of the early 21st century, there was no empirical data supporting the idea of alien architecture. Agency officials described their approach as open and methodical, relying on reproducible measurements, higher resolution imagery, and rigorous geological analysis. In addition to visual observations, NASA conducted comparative studies of Martian geology. Scientists examined similar formations in other regions of Mars and noted that mesas and plateaus with angular ridges are common throughout the planet. In official publications, NASA explained that these formations are consistent with erosion of sedimentary rock layers and the effects of wind, dust storms, and temperature fluctuations over millions of years. This comparative approach reinforced the conclusion that Cydonia's features were not unique or indicative of intelligent design. NASA also addressed claims of anomalies and image manipulation. Throughout the late 20th and early 21st centuries, some members of the public alleged that NASA had altered or censored images of Cydonia. Official statements firmly rejected these assertions. Agency representatives clarified that image processing is a standard practice in planetary science, intended to enhance clarity, correct for camera distortions, and adjust contrast for scientific analysis. These procedures do not create or remove features, and raw images are archived and made publicly available for independent review. NASA encouraged researchers and enthusiasts to access the original data to verify findings. In 2001, NASA released additional images from the Mars Orbiter camera aboard the Mars Global Surveyor. These images, captured under different lighting conditions and at higher resolution, showed the region in greater detail. NASA's press releases noted that the formations, including the so-called face, were revealed to be irregular mesas with eroded peaks and valleys. Shadows that had previously created the illusion of eyes, a nose, and a mouth were no longer aligned in the same way, further supporting the interpretation that the appearance of a face was coincidental. NASA officials emphasized that the scientific consensus regarding Cydonia had not changed. The features are naturally occurring, and there is no evidence of artificial construction. NASA's statements also highlighted the importance of public engagement while maintaining scientific rigor. Officials acknowledged that fascination with the face on Mars inspired interest in planetary exploration and astronomy. Agency communications encouraged curiosity, but stressed that extraordinary claims require extraordinary evidence. In press briefings and educational materials, NASA repeatedly explained the natural processes responsible for Martian landscapes, including volcanic activity, sediment deposition, wind erosion, and impact cratering. These explanations provided context for understanding why human brains might interpret random landforms as familiar shapes. The agency also provided detailed technical explanations for the apparent symmetry observed in Cydonia. Mesa formations often develop flat tops and steep sides due to the erosion of layered rock over long time periods. This can create straight edges and angular features that appear geometric when viewed from orbit. NASA scientists explained that lighting conditions at different times of day can dramatically change the appearance of these features, making ridges and depressions appear aligned or face-like from certain angles. The official stance was that these optical illusions, combined with the low-resolution imagery, accounted for the face on Mars phenomenon. In addition to images, NASA used computer modeling to simulate lighting on Martian terrain. By recreating the angle of the Sun and the topography of the mesas, researchers could predict how shadows would fall and how the formations would appear from orbit. These models confirmed that the face-like appearance was a transient visual effect, dependent on sunlight direction, image resolution, and perspective. NASA emphasized that the models were based on measurable topography and did not rely on interpretation or speculation. NASA's official documentation consistently addressed other claims associated with Cydonia, such as alleged pyramids or grid-like structures. The agency explained that mesas and ridges can naturally form shapes resembling triangles or straight lines. In official reports, NASA scientists compared Martian formations to desert mesas and plateaus on Earth, noting that similar shapes can arise from sedimentary layering, erosion, and tectonic fracturing. The conclusion remained that no credible evidence supported the idea that these formations were constructed by intelligent beings. Throughout the early 21st century, NASA continued to monitor and study Mars with increasingly advanced instruments, including the Mars Reconnaissance Orbiter launched in 2005. High-resolution imagery and topographic data from these missions further confirmed previous findings about Cydonia. NASA scientists reported that the formations consisted of layered rock, sand, and sediment, sculpted over millions of years by natural forces. Official communications reaffirmed that the face on Mars and nearby formations were examples of geological phenomena rather than artifacts of alien construction. NASA also emphasized transparency in sharing data with the scientific community and the public. Raw and processed images from Mars missions were archived and made available for independent analysis. Official statements encouraged researchers, educators, and enthusiasts to examine the data themselves. NASA described this openness as part of its commitment to scientific integrity, allowing anyone to verify conclusions regarding Cydonia and other Martian regions. In summary, NASA's official stance on Cydonia has been consistent, careful, and scientifically grounded. From the first Viking images in 1976 to high-resolution photographs and topographic measurements in the 21st century, the agency has repeatedly concluded that the so-called face on Mars and surrounding formations are natural features. NASA attributes their appearance to the combination of low-resolution imagery, lighting and shadow effects, and geological processes such as erosion and sedimentary layering. The agency has explicitly rejected claims of artificial construction and image manipulation, explaining that standard image processing techniques are applied solely for scientific analysis. NASA's communication strategy balances public curiosity with scientific rigor. Officials acknowledge that the face on Mars captured imaginations worldwide, but consistently remind the public that scientific evidence does not support the existence of artificial structures. By providing access to raw data, publishing detailed analyses, and using computer modeling to simulate lighting and topography, NASA has demonstrated a commitment to transparency and empirical investigation. The official narrative portrays Cydonia as a region of natural geological interest, illustrating the complex interactions between planetary processes, sunlight, and human perception. The agency also recognizes the educational value of the Cydonia phenomenon. While it does not support claims of alien architecture, NASA uses the public fascination to highlight the importance of planetary exploration, geology, and critical thinking. In press briefings, educational programs, and mission reports, the agency explains how images can be misleading and why careful analysis is essential to scientific conclusions. By addressing misconceptions and presenting clear evidence, NASA reinforces the principles of observation, measurement, and skepticism that underpin all scientific inquiry. NASA's position has been reinforced by decades of additional Mars research. Orbital missions, rovers, and landers have provided detailed maps, high-resolution images, and geological samples from multiple regions of Mars. Analysis of this data has confirmed the prevalence of mesas, ridges, and eroded plateaus across the planet. The Cydonia region, while visually intriguing, fits within this broader pattern of Martian geology. Official statements emphasize that no exceptional features in Cydonia indicate artificial origin. The agency continues to use these findings to educate the public about planetary science and the natural processes shaping Mars. Over the course of nearly 5 decades, NASA has maintained a consistent message. Cydonia is a region shaped by natural forces, and the face on Mars is an optical illusion, amplified by low-resolution imagery and human perception. The agency's official communications, mission reports, and press briefings have consistently explained the scientific methods used to reach this conclusion, including photogrammetry, computer modeling, comparative analysis, and high-resolution imaging. NASA has addressed public fascination and conspiracy theories with transparency, emphasizing that scientific conclusions rely on evidence rather than imagination. Even as technology improves and new Mars missions continue to gather data, NASA's official stance remains unchanged. The agency acknowledges that human curiosity drives interest in phenomena like Cydonia, but maintains that extraordinary claims must be supported by extraordinary evidence. By providing open access to data, clear explanations of geological processes, and rigorous analysis of imagery, NASA ensures that public interest in the face on Mars is met with scientific clarity and integrity. The region known as Cydonia on the planet Mars has long fascinated scientists, enthusiasts, and the public alike, not merely because of the physical features it presents, but because of the way human imagination interacts with what we see there. From the first blurry images transmitted by early Mars orbiters to the highly detailed photographs captured by modern satellites, our perception of Cydonia has been shaped as much by the mind as by the machines peering across millions of miles of space. When the first close-up images of the Cydonia region arrived on Earth in the 1970s, the quality of these photographs was limited by the technology of the time. The Viking missions in 1976 provided images that were, by today's standards, low in resolution, somewhat grainy, and lacking in the clarity we have come to expect. Among these images, one feature stood out immediately to many viewers, a formation that, from certain angles, resembled a human face. The so-called face on Mars became an instant curiosity, drawing the attention not only of scientists but also of the public and media. What was striking was how the simple arrangement of hills, valleys and shadows could appear so familiar, a phenomenon that demonstrates the extraordinary power of imagination and pattern recognition. Humans are inherently prone to what psychologists call pareidolia, a tendency to perceive familiar shapes, faces or objects where none actually exist. The face on Mars is a textbook example. It illustrates how, when confronted with ambiguous stimuli, the mind searches for familiar structures, often imposing order and intent onto random or natural formations. The impact of imagination on the interpretation of Cydonia's images is profound. Early observers, armed with these grainy Viking photographs, could not rely solely on objective data. Their perceptions were shaped by their own experiences, expectations, and cultural references. Some saw a deliberate construction, perhaps the work of an ancient Martian civilization, while others, more cautious or scientifically minded, noted that erosion, wind, and natural geological processes could account for the formation. In both cases, the human mind was doing its work, seeking patterns and connections, extrapolating significance from a combination of limited information and deeply ingrained cognitive habits. This interplay between perception and interpretation demonstrates that even in the age of advanced imaging technology, the human imagination remains an active participant in the process of discovery. We do not merely observe, we interpret, infer and embellish, often without conscious awareness. The story of imagination in Cydonia did not end with the Viking missions. In the 1990s and the early 21st century, new orbital spacecraft provided increasingly detailed images of the region. The Mars Global Surveyor, which began mapping the planet in 1997, captured photographs that revealed finer details of the Cydonia landscape. In these later images, the face on Mars appeared less like a human visage and more like an eroded mesa, its features smoothed by millions of years of wind and dust. The higher resolution seemed to challenge the earlier interpretations, suggesting that what had appeared to be a face was, in reality, a coincidental arrangement of natural formations. Yet even with these improved images, the power of imagination remained. Some observers noted that depending on lighting, angle and shadow, the face could still appear perceptible. This highlighted the dynamic interplay between physical reality and human perception. Imagination is not a passive lens. It is an active force that can reshape the significance of what is seen, even in the presence of clear evidence. The role of imagination extends beyond merely seeing familiar forms in natural structures. It shapes theories, speculation, and even scientific inquiry. The notion that the Cydonia region might contain evidence of an ancient civilization prompted a wave of hypotheses and studies, some grounded in rigorous analysis, others more speculative or imaginative. Books, documentaries, and public discussions proliferated, each interpreting the images in ways that reflected the biases, hopes, and fears of the authors and audiences. Imagination became both a lens and a driver, guiding questions, framing debates, and influencing which anomalies were considered significant. This is not a flaw in human cognition, but rather an essential aspect of the way we explore the unknown. Without imagination, there would be little curiosity, little inquiry, and little engagement with the mysteries of distant worlds. The very fact that humans look at Cydonia and see a face, a pyramid, or other geometric arrangements speaks to the mind's ceaseless quest to find meaning, to connect the unfamiliar with the familiar. Psychologically, this phenomenon is deeply rooted in evolutionary processes. Humans evolved as pattern-seeking organisms, recognizing faces, detecting threats, and finding order in chaos were essential for survival. These cognitive abilities, which once served practical purposes on Earth, now influence how we interpret features on distant planets. The human mind does not passively record information. It actively constructs narratives and meaning from what is perceived. In the context of Cydonia, this means that every observer brings to the table a unique set of experiences, expectations, and cultural frameworks. A scientist trained in geology may focus on erosion patterns and sedimentary layers, while an enthusiast fascinated by extraterrestrial life may see traces of civilization. Both interpretations are shaped by imagination, and both reflect the interplay between observation and cognition. Cultural context also plays a pivotal role. The fascination with Cydonia emerged in an era when space exploration was capturing the public imagination. In the 1970s, science fiction was thriving, with books, movies, and television shows depicting distant worlds populated by intelligent life. The arrival of Viking images coincided with this cultural moment, providing a fertile ground for imaginative interpretations. The idea of a face on Mars resonated with existing narratives of human-like beings across the solar system, amplifying the sense of mystery and significance. Imagination, therefore, is not purely individual. It is collective, shaped by the broader cultural landscape and reinforced by media, discussion, and shared curiosity. Another layer of imagination involves the scientific community itself. While rigorous analysis ultimately concluded that Cydonia's features are natural formations, the process of investigation was informed by imaginative hypotheses. Scientists proposed various models to explain unusual shapes, considered the effects of erosion and geological forces, and even entertained speculative scenarios, all while remaining grounded in evidence. Imagination in this context functions as a tool of inquiry, allowing researchers to explore possibilities, design tests, and anticipate outcomes. The balance between imagination and empirical rigor is delicate but essential. Without imaginative thinking, hypotheses might never arise. Without evidence, imagination risks transforming into mere fantasy. Technological advancement has further illuminated the interaction between perception and imagination. Modern orbiters and rovers, such as the Mars Reconnaissance Orbiter, launched in 2005 and equipped with the high-resolution imaging science experiment, provide unprecedented detail of the Martian surface. In these high-definition images, Cydonia's so-called face appears clearly as a natural mesa, with features shaped over eons by wind, sand, and chemical weathering. Shadows and angles that once suggested facial features are revealed as optical illusions created by sunlight striking uneven terrain. Even so, the imagination continues to operate. Observers may perceive expressions, patterns, or symbolic meaning, illustrating that imagination is not a function of low-quality imagery alone. It is a persistent human trait, shaping our perception regardless of the clarity or accuracy of the data. The dialogue between imagination and evidence is further complicated by the internet era. Images of Cydonia circulate widely online, often accompanied by commentary, speculation, and artistic interpretation. Digital manipulation, selective framing, and emphasis on certain features can amplify the perception of faces or artificial structures. In this environment, imagination intersects with social dynamics, creating a feedback loop where interpretation influences presentation, which in turn shapes perception. The result is a rich tapestry of human engagement, where scientific fact, imaginative speculation, and cultural narrative intermingle. Cydonia becomes not merely a region on Mars, but a mirror reflecting the human desire to understand, to connect, and to find meaning in the universe. Imagination also influences the emotional response to Cydonia. The perception of a face, for example, evokes familiarity, curiosity, and sometimes even awe. Humans are drawn to faces, as they signal social connection and intelligence. Seeing a face on another planet, even in illusion, triggers emotions similar to those we experience when encountering another person. These emotional reactions can motivate further investigation, inspire artistic expression, and shape public interest. They also illustrate how perception and imagination are intertwined with affective experience, making the encounter with Cydonia both intellectual and emotional. Moreover, the role of imagination extends into the philosophical and existential dimensions of human inquiry. The possibility, however remote, that features on Mars might represent evidence of past intelligence invites reflection on humanity's place in the cosmos. It encourages questions about life beyond Earth, the origins of intelligence, and the nature of reality itself. While empirical analysis indicates natural explanations for Cydonia's features, the imaginative engagement with the images fosters a broader dialogue about possibility, wonder, and the limits of human knowledge. Imagination, in this sense, is not a deviation from science, but a complement to it, expanding the horizon of inquiry and enriching our understanding of both the universe and ourselves. The history of Cydonia demonstrates that interpretation is never purely objective. Each generation of observers, equipped with different technologies, cultural frameworks, and cognitive expectations, reinterprets the images in new ways. The face on Mars has shifted from a mysterious visage in the 1970s to an eroded maser in the 21st century, yet it continues to inspire discussion and speculation. This evolution underscores the dynamic relationship between observation and imagination. What is seen is inseparable from the context in which it is perceived, and what is perceived is inseparable from the interpretive activity of the mind. On the red dusty plains of Mars, the landscape tells a story written not in words but in stone, sand, and ice. Unlike Earth, with its abundant oceans and thick protective atmosphere, Mars is a world of extremes where the elements shape the terrain with patience that spans millions, even billions, of years. Wind, ice, and erosion are the great sculptors of Martian stone, slowly crafting canyons, valleys, cliffs, and dunes that reveal the planet's long and turbulent history. Each ridge, crater, and mound is a chapter in a story of geological change, and understanding these processes allows us to glimpse a world that is both alien and surprisingly familiar. Wind is perhaps the most persistent force acting upon the Martian surface today. The planet's atmosphere is thin, less than 1% of Earth's, yet it is capable of moving enormous amounts of dust and sand over time. Dust storms, some of which can engulf the entire planet, lift fine particles from the surface and carry them across vast distances. These storms, though subtle compared to earthly hurricanes in terms of wind pressure, are relentless over the centuries. The movement of dust and sand creates features called aeolian formations, a term derived from Aeolus, the ancient Greek god of the wind. These formations include dunes, ripples, and yardangs. Yardangs are long, narrow ridges carved by persistent winds that blast loose sand against exposed rock, slowly wearing it down, much like sandpaper on wood. Their orientation often points in the prevailing wind direction, offering scientists clues about the long-term patterns of Martian wind. The sand itself is an active participant in the sculpting process. Martian sand is composed largely of broken-down basalt, a volcanic rock common on the planet's surface. Over time, repeated gusts of wind push these particles across rock surfaces, grinding them and smoothing them into shapes that might seem almost deliberate in their design, yet are entirely natural. This abrasion can form grooves, pits, and even polished surfaces on harder rock outcrops. In certain regions, such as the expansive plains of Arabia Terra and the craters of Noachis Terra, wind-driven erosion dominates the landscape, leaving behind elongated ridges, layered sedimentary deposits, and mysterious, isolated mounds that once might have been part of a larger formation, slowly whittled down by millennia of gusting winds. Ice is another critical sculptor on Mars, though its influence is more seasonal and at times more dramatic than that of the wind. Unlike Earth, Mars does not have liquid water on its surface for long periods, but it has vast amounts of water locked in ice at the poles and in subsurface layers. During the Martian winter, carbon dioxide from the thin atmosphere condenses into frost or dry ice at the poles, and water ice remains in shaded regions or buried under layers of dust. Seasonal thawing and sublimation, the transition of ice directly from solid to gas, can destabilize slopes, trigger landslides, and slowly move sediment downslope. Features such as gullies and patterned ground are often linked to the presence of ice, either historically or in current conditions. Scientists observe that some gullies resemble dry riverbeds on Earth, hinting that even small amounts of transient liquid or sublimated ice can exert significant erosive force over long periods. Ice does not act alone. Its presence interacts with the wind in fascinating ways, producing formations unique to Mars. For instance, in the polar regions, the combination of frost, sublimation, and seasonal winds creates the so-called spider formations. These structures consist of radial channels etched into the ground, formed when carbon dioxide ice trapped under the surface is heated by the weak Martian sun, causing gas to erupt violently through cracks and carry dust with it. Over time, these eruptions carve intricate dendritic patterns into the terrain. While they might appear artistic or deliberate, they are the result of predictable, natural processes driven by the extreme cold, thin atmosphere, and diurnal temperature variations of Mars. Erosion on Mars is both ancient and ongoing. The planet's surface is dotted with craters, many of which are billions of years old, formed by meteorite impacts during the early history of the solar system. These craters, originally sharp and well-defined, have been softened over eons by wind and ice. The edges crumble, walls slump, and floors fill with sediment, creating layers that record a timeline of geological events. In some areas, scientists find sedimentary layering reminiscent of desert basins on Earth, where wind and water once collaborated to deposit fine sands and silts. In others, they find volcanic deposits partially eroded by wind, forming hills and ridges that offer clues about the planet's volcanic past. Volcanic activity has also contributed indirectly to erosion by supplying loose material for the wind to move. Mars hosts some of the largest volcanoes in the solar system, including Olympus Mons, which towers over 21 kilometers above the surrounding plains. Lava flows, ash deposits, and pyroclastic material from these volcanoes provide abundant debris that wind can shape over time. Even long after volcanic activity ceased, these materials are gradually sculpted by natural forces. Valleys carved by catastrophic floods in the distant past, such as those in the region of Valles Marineris, also interact with wind and ice today. Sediment left behind by these floods can be redistributed by seasonal winds, slowly reconfiguring the Martian surface in ways that are subtle yet profound over geological timescales. Water, though currently scarce on the surface, played a crucial role in shaping Mars in its distant past. Billions of years ago, during the Noachian period, Mars had rivers, lakes, and perhaps even shallow seas. The valleys and channels left behind indicate that water once flowed with sufficient volume to erode rock, transport sediment, and carve valleys that now stretch for hundreds of kilometers. As Mars cooled and lost much of its atmosphere, liquid water became unstable, leaving behind features that testify to its presence. Wind and ice have since continued the process of shaping these ancient waterways. Dust fills the dry riverbeds, ice wedges expand and contract, and seasonal temperature changes cause minor movements in the regolith, gradually modifying these channels. Even today, in areas such as the Highland craters and equatorial plains, scientists see evidence of layered deposits that suggest sedimentary processes influenced by water, later altered by wind and ice. One of the most striking aspects of Martian erosion is its slow pace compared to Earth. The thin atmosphere and cold temperatures mean that processes such as wind abrasion and frost action operate over thousands, tens of thousands, or millions of years to produce noticeable changes. Yet, despite the slow rate, the cumulative effect is profound. Entire landscapes, once dominated by volcanic plains or cratered highlands, can be reshaped into undulating dunes, eroded mesas, and softened crater rims. The juxtaposition of sharp ridges and smooth plains in regions such as Tharsis and Elysium Planitia reveals the delicate balance between forces that build and forces that wear down. The interplay of wind, ice, and erosion also preserves a record of Martian climate. Layers within sedimentary rocks, the orientation of dunes, and the patterns of frost-related features all serve as archives of environmental conditions. For instance, cross-bedded sandstones in Gale Crater, where the Mars Science Laboratory rover Curiosity explored, indicate that ancient wind directions shifted over time. Frost polygons in the polar regions suggest cyclical freezing and thawing, hinting at long-term variations in temperature and atmospheric pressure. By studying these natural sculptures, scientists can reconstruct a timeline of Mars' climate history, revealing periods of warmth, cold, aridity, and episodic moisture. Mars' geological diversity is amplified by the interaction of these sculptors with the planet's composition. The widespread presence of basalt, a dark volcanic rock, contrasts with lighter-coloured sedimentary deposits, creating a visual record of different processes. Iron-rich dust gives the planet its signature reddish hue, while variations in mineralogy, reveal the chemical fingerprints of water, wind, and ice over time. Some regions display a patchwork of eroded plains, fractured bedrock, and layered sediments, all testimony to the combined work of wind, ice, and ancient water. The concept of erosion on Mars also helps explain features that might at first seem mysterious. Towering mesas, isolated hills, and strange linear ridges can appear artificial or deliberately constructed, but natural processes provide plausible explanations. Mesa formation, for example, occurs when a resistant rock layer protects the underlying softer material from wind and ice erosion. Over millions of years, the surrounding softer rock wears away, leaving behind a flat-topped, steep-sided hill. Similarly, ridges and grooves can form through the repeated action of wind-moving sand and dust across softer layers of rock, or through the expansion and contraction of ice in the soil. These features, remarkable in their geometry, are the result of patient, methodical natural forces rather than conscious design. Seasonal and long-term cycles also play a role in Martian erosion. During the Martian spring and summer, temperatures rise slightly, allowing frost to sublimate and dust to become airborne. During the long, cold winters, ice accumulates and soils contract. Over thousands of years, these cycles cause repeated expansion, contraction, and movement in the surface materials, gradually altering the landscape. The effect is similar to freeze-thaw processes on Earth, which break down rocks and move soil, but adapted to the extreme conditions of the Martian environment. Even the towering canyon system of Valles Marineris owes its current appearance to wind, ice, and erosion, long after its initial formation through tectonic and possibly catastrophic flood processes. The steep canyon walls show evidence of landslides, fallen debris, and dust accumulation, all modified by aeolian action. Small gullies and channels on the canyon floors hint at frost activity and episodic flows of briny water in the past. The combination of ancient geological forces with ongoing erosion creates a dynamic, ever-changing landscape that continues to evolve, albeit at a pace far slower than on Earth. The quest to understand Mars has been one of the most fascinating and enduring adventures of human curiosity, stretching back over a century and a half. While the region of Cydonia has long captured the public imagination, due to its strangely shaped landforms and the mysterious face on Mars, scientists and explorers have never limited their efforts to that single area. The search for life on the red planet extends far beyond Cydonia, reaching into valleys, craters, polar regions, ancient riverbeds, and even the invisible depths beneath the planet's surface. The pursuit of Martian life is not just a modern endeavour, it is the culmination of centuries of observation, speculation, and technological ingenuity, a journey that mirrors humanity's unquenchable thirst for understanding its place in the cosmos. From the earliest telescopic observations in the 1800s, astronomers were captivated by the reddish glow of Mars in the night sky. Italian astronomer Giovanni Schiaparelli, in the year 1877, described linear features on the Martian surface that he called canali, which literally meant channels. While he intended this as a neutral term, it was mistranslated into English as canals, suggesting artificial construction, and ignited speculation that intelligent life might be engineering these features. In the decades that followed, popular imagination filled the void of concrete knowledge with visions of Martian civilizations, exotic flora and fauna, and bustling cities beneath the planet's thin atmosphere. The reality, of course, has been far more subtle, and yet no less thrilling. Mars is a world shaped by water, wind, ice, and volcanism, each of which holds clues to whether life might have once thrived there, or may persist even today in hidden niches. The broader search for life beyond the Cydonia region has involved meticulous investigation of many areas that show evidence of water in its various forms. Mars is a cold and arid planet, but numerous geological features suggest that liquid water was once abundant. Ancient river valleys, some stretching for hundreds of kilometers, win their way across the surface, revealing channels carved by flowing water over billions of years. Craters often contain sedimentary deposits that resemble lake beds on Earth, and minerals such as clays and sulfates, which form in the presence of water, have been identified across the Martian landscape. Scientists studying these features know that water is a fundamental ingredient for life as we understand it, and wherever it has persisted, there may have been the possibility for life to emerge. One of the most remarkable findings in the exploration of Mars is the presence of recurring slope lineae, narrow streaks that appear seasonally on steep slopes, darkening and then fading with the changing temperature. First observed in the year 2011 by the Mars Reconnaissance Orbiter, these streaks are believed to involve the transient flow of briny water during the warmer months. While small in scale, they suggest that liquid water can exist today, even under the harsh conditions of the Martian surface. This has profound implications for the search for microbial life, as pockets of salty liquid water could serve as temporary habitats for extremophils, organisms adapted to survive in extreme environments, similar to those found in Antarctic ice or deep-sea hydrothermal vents on Earth. Beyond water, scientists have pursued chemical signs of life, looking for organic molecules and the building blocks that underpin all known biological systems. The Viking missions of the 1970s, despite being decades ago, were pioneering in this regard. They included experiments designed to detect metabolism in Martian soil samples, which yielded puzzling results that continue to be debated to this day. Some scientists interpret these findings as evidence of complex chemical reactions, while others caution that non-biological processes can mimic these signals. In the following decades, more advanced instruments aboard rovers and orbiters, such as the Curiosity rover in the year 2012 and the Perseverance rover in the year 2020, have detected a variety of organic compounds preserved in rocks that date back billions of years. These compounds, including carbon-based molecules, suggest that Mars once had conditions conducive to life, even if no direct evidence of living organisms has yet been discovered. Mars's polar regions, often overlooked in popular discussions, also hold tantalizing clues. The planet's north and south poles are capped with layers of ice that extend for kilometers, and these layers contain records of climatic shifts stretching back millions of years. Radar instruments aboard orbiters have detected vast reservoirs of water ice beneath the surface, and in some cases these hidden lakes could contain liquid water, insulated by ice and salts. Such environments could provide a refuge for life, shielded from harsh radiation and extreme temperature fluctuations. On Earth, microbes thrive in subglacial lakes and deep ice cores, hinting that Mars might harbour similar forms of life in its frozen depths. The prospect of discovering living organisms or even remnants of past life beneath the ice has inspired mission concepts that include drilling and sampling these hidden reservoirs, although the technical challenges remain enormous. Meteorites from Mars that have landed on Earth also contribute to the broader search for life. Over the centuries, scientists have identified several Martian meteorites, such as ALH 802001 and NACLA, that contain features reminiscent of microbial activity. Microscopic structures resembling fossilized bacteria and organic compounds have been reported in some of these rocks, though interpretations remain controversial. These meteorites are invaluable because they allow researchers to study Martian material in laboratories with precision instruments far beyond what can be deployed on rovers. Even without sending humans to Mars, these fragments provide a tangible connection to a world millions of kilometers away, and they continually fuel the debate about whether life ever existed there. The advent of robotic rovers and orbiters has revolutionized the study of Mars, allowing scientists to examine the planet's surface with unprecedented detail. The Mars exploration rovers, Spirit and Opportunity, landed in the year 2004, revealing vast plains of iron-rich soil and evidence of ancient water flow. Opportunity, in particular, traversed the Meridiani Planum region for nearly 15 years, uncovering sedimentary layers and mineral deposits that hinted at past wet environments. Spirit, meanwhile, explored the Gusev crater, identifying volcanic rocks and soil altered by water, painting a picture of a dynamic planet that experienced dramatic environmental changes over eons. The success of these missions demonstrated that robotic explorers could not only survive in the harsh Martian environment, but also gather data essential to understanding the planet's potential to support life. Building on these achievements, the Mars Science Laboratory mission, led by the Curiosity rover, has provided a wealth of information about Mars's habitability. Landing in Gale Crater in the year 2012, Curiosity examined layered sedimentary rocks that preserve a history of ancient lakes and river deltas. Its sophisticated suite of instruments detected organic molecules, fluctuating methane levels in the atmosphere, and variations in environmental conditions that would have been favourable for microbial life. Methane, in particular, is intriguing because it can be produced by biological processes as well as geological ones. Curiosity's findings suggest that Mars has a more complex and active chemical environment than previously imagined, keeping the possibility of past or present life alive in the minds of scientists. Perseverance, landing in the Jezero crater in the year 2020, represents the next stage in this ongoing quest. Jezero was chosen because it once housed a lake and a river delta, making it a prime location for preserving evidence of ancient life. Perseverance is not only exploring the surface, but also collecting rock and soil samples that are intended to be returned to Earth by future missions. These samples could allow for laboratory analyses that are far more sensitive and comprehensive than what is possible on Mars, potentially revealing microfossils or chemical biosignatures that would confirm the existence of life at some point in the planet's history. The mission also carries instruments designed to test the production of oxygen from carbon dioxide, a technology that could support future human explorers and deepen our understanding of Mars's atmospheric chemistry. The study of Martian meteorology and climate further informs the search for life. Seasonal changes in temperature, dust storms, and variations in atmospheric pressure all influence the availability of water and the potential for habitable conditions. Mars's thin atmosphere, composed primarily of carbon dioxide, provides little protection from ultraviolet radiation, which poses a major challenge for life on the surface. However, subsurface niches, shaded rock formations, and polar ice could offer protection, creating microenvironments where life might survive. By combining orbital observations with surface measurements, scientists are constructing detailed models of Mars's climate history, identifying periods when the planet may have been warmer and wetter, conditions under which life could have originated and thrived. The possibility of extremophile life forms, which thrive in extreme conditions on Earth, has shaped much of the modern search strategy. Organisms that survive in boiling acidic springs, frozen tundras, or deep underground without sunlight expand the range of conditions under which scientists consider life possible. By analogy, Martian microbes could exist in briny subsurface waters, within salty soil layers, or beneath rocks that shield them from radiation. Laboratory simulations on Earth, combined with observations from rovers and landers, help refine these hypotheses and guide the selection of target sites for exploration. The discovery of even the simplest microbial life on Mars would revolutionize our understanding of biology, demonstrating that life can emerge independently on other worlds. International collaboration has also become a key part of the broader search for Martian life. Space agencies from Europe, Russia, India, China, and the United Arab Emirates have launched orbiters, landers, and planned rovers that complement NASA's missions. Instruments on these spacecraft detect atmospheric gases, surface minerals, and subsurface structures, providing multiple lines of evidence about Mars's habitability. The convergence of data from different missions allows scientists to cross-verify findings and build a more coherent picture of the planet's environment. This global effort underscores the idea that the quest for life on Mars transcends national boundaries, reflecting a shared human curiosity about the universe and our origins. Astrobiologists are also exploring the potential for life not only on the surface, but in Martian caves and lava tubes, which could offer stable environments shielded from radiation and temperature extremes. These subterranean habitats may contain water ice, or even liquid water maintained by geothermal heat, providing a sanctuary for life to survive long after surface conditions became inhospitable. Investigating these hidden spaces is technically challenging, but the rewards could be immense. Finding evidence of life in such locations would expand our understanding of the diversity of life-supporting environments beyond Earth, and could inform future missions that aim to explore Mars more deeply. In addition to the search for microbial life, scientists consider the long-term implications of habitability and the potential for life to adapt to Martian conditions. The concept of panspermia, the idea that life can be transported between planets via meteorites, suggests that Earth and Mars may share a biological connection, with microorganisms potentially surviving the harsh journey through space. While this remains speculative, it adds another dimension to the search, motivating careful study of Martian soils, rocks, and atmospheric conditions for signs of organic material that might indicate past or present life. As missions continue, The technological toolkit for exploring Mars grows increasingly sophisticated. Drones like the Ingenuity helicopter, which first flew in the year 2021, provide aerial reconnaissance that allows scientists to survey terrain that would be difficult or impossible to reach with rovers alone. Advanced instruments for spectroscopy, imaging, and chemical analysis allow detailed studies of mineral composition and organic content. Sample caching systems and planned sample return missions promise to deliver Martian material to Earth laboratories, where decades of experience and cutting-edge instruments can be brought to bear in the search for definitive evidence of life. The broader search for Martian life is a careful balance of optimism and scientific rigor. While the region of Cydonia remains a source of fascination due to its unusual landforms, the evidence for life, or conditions that could support life, extends across the planet. Each river valley, crater, polar ice cap, and hidden cave adds a piece to the puzzle, revealing Mars as a world that has undergone dramatic environmental transformations over billions of years. Scientists recognize that finding life on Mars, even at the microbial level, would be one of the most profound discoveries in human history, altering our understanding of biology, planetary science, and our place in the cosmos. The journey to uncover Martian life is far from complete. It is a story that unfolds across vast distances and immense spans of time, combining observations from the 19th century to the present day, using telescopes, orbiters, rovers, landers, and laboratory analyses. Each mission builds on the knowledge gained from previous explorations, refining hypotheses, testing instruments, and uncovering new questions that push the boundaries of human understanding. The search encompasses not only the tantalizing features of Cydonia, but also the entire planet, from equatorial plains to highland plateaus, from ancient lake beds to the hidden reservoirs of ice beneath the surface. As technology continues to advance, the next decades promise even more daring explorations. Human missions to Mars, long considered the stuff of science fiction, are now moving toward the realm of possibility, potentially allowing direct investigation of Martian rocks, soils, and underground environments. The prospect of humans walking across ancient riverbeds, drilling into ice layers, and collecting samples from previously inaccessible regions opens new horizons for discovering signs of life. Each step brings humanity closer to answering the question that has driven astronomers, scientists, and dreamers for centuries. Is life unique to Earth, or does it exist elsewhere in the universe? Each mission, each analysis, and each observation adds layers of knowledge and complexity, revealing a world that is far from dead, even if it appears barren from orbit. Mars is a planet of extremes and contrasts: frozen deserts, dusty plains, towering volcanoes, deep canyons, and hidden waters. These features provide countless opportunities for life to exist in forms both familiar and alien, challenging our assumptions and expanding the horizon of possibility. The broader search for life on Mars is therefore not merely about finding microbes or fossils. It is about exploring the fundamental question of our place in the universe and whether life is a singular miracle of Earth or a widespread phenomenon in the cosmos. Cydonia, a region on the planet Mars, has held a unique place in the history of human exploration of that distant world, capturing both the scientific curiosity of astronomers and the imagination of the general public. Its story begins in the early years of space exploration, at a time when humanity was only beginning to peer at the red planet with instruments powerful enough to reveal its surface in meaningful detail. For centuries, Mars had been a source of wonder and speculation, visible as a bright ruddy dot in the night sky, inspiring myths, legends, and speculation about the possibility of life beyond Earth. The planet's distinctive reddish colour, caused by iron oxide dust covering its surface, made it a compelling target for observation and imagination alike. Yet it was not until the advent of spacecraft in the mid-20th century that humans could truly begin to map, photograph, and analyse its landscapes in a systematic and detailed way. The region known as Cydonia gained prominence largely because of its unusual topography and the patterns visible from early photographs sent back by orbiting spacecraft. Located in the northern hemisphere of Mars, roughly between 38 and 41 degrees north latitude and around 3 and 54 degrees west longitude, Cydonia presented a series of mesas, buttes, and unusual formations that, in low-resolution images, appeared to some observers as having symmetrical and geometric shapes. Among these formations, one in particular drew extraordinary attention, a formation resembling a human face. This so-called face on Mars was first imaged by the Viking 1 orbiter on July 25, 1976, and its resemblance to human facial features was immediately striking. In the grainy black and white images returned by Viking, the formation appeared to have eyes, a nose, and a mouth, giving it an almost uncanny likeness to a human visage staring up from the Martian plains. The impact of this discovery on both the scientific community and the public cannot be overstated. To many scientists, the initial images were intriguing, but they emphasized the limitations of the technology of the time and cautioned against overinterpretation. Photographic artifacts, shadows, and the low resolution of the images could easily create illusions of patterns and shapes where none actually existed. The Viking orbiters were equipped with cameras capable of resolving features down to roughly 50 meters across, meaning that finer details of the surface could not be captured, and subtle differences in lighting or angle could dramatically alter the appearance of formations. Yet, to the public and to certain enthusiasts, the face on Mars sparked intense speculation and fascination. Books, television programs, and articles explored the possibility that Cydonia might contain relics of an ancient Martian civilization, inspiring widespread interest in the mysteries of the Red Planet. Following the Viking missions, Cydonia remained a subject of debate and intrigue, largely because subsequent missions to Mars initially focused on other priorities, such as planetary geology, climate, and the search for water. The Viking orbiters themselves collected vast amounts of data, mapping much of Mars and studying its atmosphere and surface composition. Scientists analyzing these data found evidence of ancient river valleys, dried-up lake beds, and sedimentary formations that suggested the planet had once experienced a very different climate. Cydonia, however, with its enigmatic mesas and the notorious face, remained a minor but persistent enigma in these studies. The formations were noted in geological surveys and often referred to as Cydonia mensae, meaning the plateau-like regions of Cydonia. These mesa-like structures were later understood to be the result of erosion, volcanic activity, or other natural geological processes, but the allure of the face, especially in the minds of the public, endured. In the decades following the Viking missions, advancements in imaging technology allowed for a more detailed examination of Cydonia. By the late 1990s and early 21st century, new orbiters equipped with higher resolution cameras revisited the region, providing images that offered unprecedented clarity. The Mars Global Surveyor, which entered orbit around Mars in 1997, and later the Mars Reconnaissance Orbiter, launched in 2005, returned images of Cydonia at resolutions as fine as 1 meter per pixel. These images revealed that the face was, in reality, a natural mesa formation shaped by the interaction of wind, erosion, and the deposition of Martian dust and rocks over millions of years. Shadows that had created the illusion of eyes, a nose, and a mouth in the Viking images were now understood to be a product of lighting and perspective, not evidence of artificial construction. The scientific community emphasized that while Cydonia was geologically interesting, there was no evidence of structures created by intelligent beings. Despite the scientific clarifications, the fascination with Cydonia continued to flourish in popular culture. The persistence of the face on Mars as a symbol of mystery highlights a broader theme in the history of Mars exploration, the interplay between imagination and observation. Human beings have a tendency to seek patterns and meaning, even in random or natural formations, a phenomenon known as pareidolia. The face on Mars exemplifies this phenomenon perfectly. While scientific analysis provided a clear explanation for its appearance, the public narrative often emphasized speculation, conspiracy theories, and the tantalizing possibility of ancient Martian life. Some individuals suggested that NASA and other space agencies deliberately obscured or downplayed evidence of intelligent life on Mars, leading to a cottage industry of whistleblower claims, speculative documentaries, and alternative theories. The region became a focal point for discussions about what humanity hopes to find on other worlds, reflecting our deep-seated curiosity and desire to encounter something truly alien yet recognizable. Beyond the face, Cydonia itself holds significant scientific importance because it exemplifies the diversity of Martian geology. The region contains a mixture of flat plains, mesa-like hills, and eroded landforms, making it a natural laboratory for studying the processes that shape planetary surfaces. Geologists study formations in Cydonia to understand the history of Martian erosion, sedimentation, and tectonic activity. By examining the layering of rocks, the shapes of mesas, and the patterns of sediment deposits, scientists can reconstruct the environmental conditions that existed billions of years ago, offering clues about the planet's climate evolution and its potential to have supported life. The region's mesas and depressions are similar in some respects to desert formations on Earth, such as those found in the American Southwest, where wind and water have carved striking landscapes over millions of years. Comparing these Martian features with terrestrial analogues allows researchers to test hypotheses about how water, ice, and wind have interacted on Mars over geological timescales. Cydonia's prominence in the history of Mars exploration also lies in its role as a symbol of how scientific understanding evolves. Initial observations, limited by technology and perspective, led to speculation and imaginative interpretations. Over time, as more precise instruments became available, the apparent mysteries were clarified, yet the public fascination remained. This progression illustrates an essential aspect of planetary science. Exploration is a dynamic process, where early interpretations are often revised in light of new evidence, and where mystery and wonder coexist with rigorous scientific inquiry. Cydonia serves as a case study in how humans approach the unknown, demonstrating both the excitement of discovery and the necessity of critical analysis. The region has also played a role in inspiring scientific missions and exploration goals. The curiosity generated by formations like the Face encouraged funding and public interest in Mars missions, contributing to the eventual deployment of rovers, orbiters, and landers designed to study the planet in unprecedented detail. Each new mission built upon the foundation laid by earlier explorers, both human and robotic, creating a cumulative understanding of Mars as a complex, dynamic world. In this way, Cydonia's impact extends beyond the specifics of its geography. It helped to shape the trajectory of human inquiry, motivating further exploration and providing a tangible example of why Mars captivates the imagination. In addition, the controversy surrounding Cydonia illustrates the broader cultural dimensions of space exploration. The debate over the face on Mars engaged not only scientists but also artists, writers, filmmakers, and amateur astronomers. The region became a nexus where science, speculation, and popular culture intersected. Documentaries, science fiction novels, and speculative analyses proliferated, sometimes blurring the line between fact and fiction. This phenomenon underscores a recurring pattern in human interaction with space. Extraordinary landscapes inspire extraordinary stories. From a scientific perspective, Cydonia remains valuable because it illustrates the importance of high-resolution imaging and long-term monitoring of planetary surfaces. The differences between the initial Viking images and later high-resolution images highlight how much our understanding can change with improved technology. For planetary scientists, regions like Cydonia are opportunities to test theories of erosion, sediment deposition, and the effects of Martian winds and dust storms. The interplay of light and shadow, the layering of sediments, and the morphology of mesas all provide data for models of Martian geology. These models, in turn, inform broader questions about the planet's history, including the presence of liquid water, the evolution of the atmosphere, and the potential for past habitable environments. Cydonia's history also illustrates the role of narrative in science. Early interpretations of the face on Mars were heavily influenced by the human propensity to see familiar forms in random patterns. This narrative lens shaped public perception, media coverage, and even the priorities of some research efforts. Scientists often found themselves balancing the need to address sensational claims with the task of advancing rigorous inquiry. In doing so, the Cydonia story demonstrates the delicate balance between curiosity, skepticism, and communication in the scientific process. By engaging with public fascination while providing clear evidence-based explanations, researchers help foster a more informed understanding of planetary exploration. The region continues to be a focal point in the broader search for signs of past life on Mars. While there is no evidence of artificial structures, Cydonia's geological features contribute to our understanding of environmental conditions that could have supported life billions of years ago. Studying erosion patterns, sedimentary layers, and mineral deposits help scientists identify areas where water may have existed, an essential factor in assessing habitability. In this way, Cydonia contributes indirectly to astrobiology, the field that seeks to understand the potential for life beyond Earth, even if the region itself does not harbour evidence of intelligent activity. The importance of Cydonia in Mars exploration history is thus multifaceted. It is a region that exemplifies the scientific process from initial observation through hypothesis, testing, and eventual clarification. It is a region that illustrates human perception and the tendency to seek patterns, often leading to rich narratives that captivate the public imagination. It is a region that has motivated missions, inspired discussions, and contributed to our understanding of Martian geology, erosion, and environmental history. In essence, Cydonia embodies both the mysteries of the unknown and the rewards of systematic inquiry, making it a central chapter in humanity's ongoing story of exploring the Red Planet. From a historical perspective, Cydonia serves as a touchstone for understanding how space exploration evolves over time. Each mission, from the Viking orbiters to the Mars Global Surveyor and the Mars Reconnaissance Orbiter, added layers of understanding and clarity. Each technological improvement, whether in imaging resolution, orbital mechanics, or data analysis, transformed what had once been enigmatic shadows into comprehensible geological formations. This evolution reflects the broader arc of human exploration. Initial observations often spark fascination and speculation, which then motivate further study, technological advancement, and eventually more nuanced understanding. In this sense, Cydonia is not only a geological feature, but also a symbol of the cumulative nature of knowledge, where curiosity and technology together expand the boundaries of what we know about our planetary neighbours. The enduring fascination with Cydonia also demonstrates the importance of narrative in shaping public engagement with science. The face on Mars captured imaginations not because it was an actual artifact, but because it resonated with deep human themes. The search for other life, the recognition of familiar forms in alien landscapes, and the possibility that we are not alone in the universe. These narratives, while sometimes divergent from scientific consensus, serve a valuable role in fostering interest in planetary exploration and in stimulating the next generation of scientists, engineers, and explorers. Cydonia holds an extraordinary place in the history of Mars exploration. It is a region that bridges science, imagination, and cultural fascination. Its mesas, eroded formations, and the famous face have sparked debate, inspired missions, and shaped public perception of Mars for decades. From the Viking missions of 1976 to the high-resolution surveys of the 21st century, Cydonia has demonstrated the evolution of planetary science, the importance of technological advancement, and the enduring power of human curiosity. While the mysteries once attributed to the face have been explained by natural processes, the region continues to contribute to our understanding of Mars' geological history, environmental evolution, and potential habitability. In every sense, Cydonia exemplifies the intertwined journey of discovery, imagination, and exploration that defines humanity's ongoing quest to understand the Red Planet. From the earliest days of human life on this planet, our brains have been wired in a very special and particular way. We are built to see faces. It is as though nature itself has tuned our minds to recognize the presence of other humans almost instantly, to detect emotion, to notice intention, and to establish connection. This remarkable ability is so deeply ingrained in our minds that even when no real face is present, we often perceive one where it does not exist. A piece of rock, a shadow on a wall, the patterns in the clouds, and even the features of distant landscapes can appear as faces to us. This psychological phenomenon, which scientists call pareidolia, is both fascinating and essential, reflecting our deep evolutionary history and the intricate workings of the human brain. Pareidolia is not just a casual quirk of perception, it is a powerful and consistent feature of human cognition. The term itself comes from Greek roots, para, meaning alongside or resembling, and eidolon, meaning image or form. Put simply, it describes the tendency of the mind to perceive familiar patterns, especially faces, in random or unrelated shapes. In daily life, this happens constantly, often without us even realizing it. a cloud shaped like a dragon, a tree branch that seems to wave, or the arrangement of windows and doors on an old building can all trigger this response. Our ancestors, hunting in the forests and plains of the Pleistocene epoch tens of thousands of years ago, relied on their ability to recognize faces quickly. Seeing a predator, a friendly tribe member, or a rival from a distance could mean the difference between life and death. Those who were better at detecting faces, even imperfect ones in shadows or obscured by terrain, were more likely to survive. Over countless generations, this survival mechanism became so deeply embedded that humans today are almost compelled to see faces, even in the most inanimate of objects. The brain areas involved in face recognition are particularly specialized. The fusiform face area, located in the human brain's temporal lobe, is a small but intensely active region that is dedicated almost entirely to identifying faces. When this area is stimulated, the brain rapidly pieces together patterns of eyes, nose, mouth, and other facial features, even if the face is just a random collection of marks or shadows. Experiments using functional magnetic resonance imaging, or fMRI, have shown that when people view objects that vaguely resemble faces, such as the rounded front of a car or a section of a rock face, this fusiform region lights up as though a real human face is being seen. It is an automatic process, so instantaneous that it often bypasses conscious thought. We do not choose to see faces, our minds simply insist upon it. Throughout history, humans have repeatedly interpreted ambiguous shapes in the environment as faces or anthropomorphic figures. Ancient cultures frequently carved faces into rock, painted human-like images on cave walls, and even attributed spirits or gods to natural formations. The famous faces of Mount Rushmore in the United States, the Moai statues of Easter Island, and the intricate carvings in Petra all reflect this enduring human fascination. However, even before these deliberate efforts, humans saw faces in purely natural forms. Clouds, cliffs, rivers, and rocks became canvases for imagination. The human mind, confronted with irregularities and contrasts in texture and light, instinctively projects a sense of familiarity, a face, onto them. In many ways, this tendency is an expression of our social nature. Faces represent connection, recognition, and the awareness of other minds, which are critical for trust, empathy, and communication. In the realm of extraterrestrial landscapes such as the planet Mars, pareidolia plays a striking and sometimes controversial role. The most famous example is the so-called face on Mars, located in a region known as Cydonia. In 1976, the Viking 1 orbiter captured images of a mesa that, from a particular angle and under specific lighting conditions, resembled a humanoid face. The resemblance was uncanny. There appeared to be two darkened areas like eyes, a shadowed groove suggesting a nose, and a horizontal indentation that could be interpreted as a mouth. Newspapers and media outlets around the world reported the discovery, often sensationalizing the image as proof of ancient Martian civilizations. But the image itself was only about 220 meters across, a scale roughly comparable to 2 American football fields laid end to end. When viewed from orbit, this structure seemed eerily human-like. The phenomenon was a textbook case of pareidolia, the human brain detecting familiar patterns in randomness and projecting a face onto a natural rock formation. The interpretation of the Martian face illustrates a broader psychological principle. Context shapes perception. The structure in Cydonia was viewed not in isolation, but within a narrative of curiosity, imagination, and desire for discovery. Humans are storytellers by nature. We seek patterns, narratives, and explanations even in incomplete information. When people first saw the image, their minds instinctively searched for meaning. The brain's facial recognition mechanisms triggered the perception of a face, while the surrounding context, Mars as an alien and intriguing world, encouraged speculation about life, intelligence, and history. In essence, the face on Mars was never necessarily a deliberate construction by a Martian civilization. It was a mirror reflecting human psychology, a canvas on which imagination and expectation painted a familiar image. This phenomenon is not limited to Mars. Across human experience, pareidolia shapes perception and imagination. In astronomy, craters on the Moon, features on distant planets, and irregularities in asteroid shapes have all been described as faces or creatures. On Earth, rock formations like the Old Man of the Mountain in New Hampshire, which collapsed in 2003, and the Sleeping Giant in Ontario have inspired myths, legends, and local folklore. The interpretation of these formations as faces or figures is universal across cultures and centuries. Anthropologists have noted that in almost every society, natural forms resembling faces or human figures acquire stories, meanings, and significance, often imbued with spiritual or cultural importance. This suggests that the recognition of faces is both biologically innate and culturally reinforced. Scientific studies have attempted to quantify the intensity and universality of pareidolia. Psychologists have shown that nearly all humans are prone to seeing faces where none exist, although susceptibility varies. Children, for example, tend to identify faces more readily than adults, perhaps because their brains are more actively engaged in learning social cues. Similarly, people with higher levels of social engagement or empathy are more likely to detect faces in ambiguous patterns. Even factors such as lighting, angle, and contrast significantly influence the perception of faces. A rock under the morning sun may seem blank, while the same rock in the afternoon, casting longer shadows across its surface, can appear to have eyes, a nose, and a mouth. The brain, ever vigilant for social stimuli, seizes upon these cues to create coherent images. Pareidolia is also linked to emotion and mood. Humans are particularly sensitive to the perception of threatening or friendly faces, a trait that may have evolved as a survival mechanism. Studies show that when people are anxious, stressed, or vigilant, they are more likely to see faces in random patterns, often interpreting them as angry, sad, or menacing. Conversely, in moments of calm or positive emotion, the faces perceived in random objects are often seen as smiling, peaceful, or benign. This interaction between internal state and visual perception underscores the intimate connection between psychology and pattern recognition. We do not simply see the world as it is, we see it as we are. Technology has provided further insight into the phenomenon. Computers and artificial intelligence, while adept at pattern recognition, generally lack the deep intuitive understanding that humans possess. Machine learning algorithms can identify faces in images with impressive accuracy, but they are trained on vast datasets and rely on statistical probabilities rather than the complex emotional and context-driven processes of the human brain. This explains why AI can sometimes fail to recognize a face that humans immediately perceive, and conversely, why AI can see faces in places humans might dismiss. The uniqueness of the human experience of pareidolia lies not in mere detection, but in interpretation, imagination, and emotional resonance. Art and culture have long explored this tension between perception and reality. In the Renaissance, artists painted faces emerging from landscapes, clouds, and drapery, deliberately exploiting pareidolia to provoke wonder and reflection. Surrealist artists of the 20th century, including Salvador Dali, explored the ambiguity of perception, creating works in which faces, figures, and forms appeared and disappeared depending on the viewer's focus. This artistic tradition is deeply tied to the same psychological mechanisms that lead humans to see faces in Martian rocks, clouds, and everyday objects. Both phenomena reflect a mind attuned to pattern, narrative, and social connection. In contemporary society, pareidolia continues to capture imagination and inspire speculation. Internet culture thrives on sharing images of faces in unexpected places, on toast, in tree bark, in shadows on walls, and even in traffic lights. Some of these images become viral sensations precisely because they resonate with a deeply human tendency: the desire to find familiarity, connection, and meaning in randomness. The phenomenon also underlies more serious psychological explorations, such as understanding hallucinations, visual misperceptions, and the ways in which the brain constructs reality. In short, pareidolia is a window into the architecture of human thought, revealing how perception, emotion, memory, and social cognition intertwine to shape the way we experience the world. Returning to the Martian example, the face on Mars provides a perfect illustration of the power of pareidolia. While initial images from 1976 were grainy, low resolution, and subject to atmospheric distortion, they triggered a cascade of speculation and storytelling that continues to this day. Later, In 1998 and 2001, higher resolution images from spacecraft like Mars Global Surveyor and Mars Reconnaissance Orbiter revealed the mesa to be a natural formation, eroded over millions of years by wind, ice, and temperature fluctuations. Yet, despite the scientific explanations, the perception of a face persisted. The human mind, once it recognizes a pattern as significant, tends to hold on to that perception, interpreting even new data through the lens of prior expectation. This is a fundamental aspect of cognitive psychology. Once a face is seen, it is difficult to unsee, and the emotional and narrative associations endure. In essence, humans see faces in rocks, clouds, and alien landscapes because our brains are exquisitely designed to detect faces, an adaptation rooted in survival, social interaction, and emotional engagement. Pareidolia is more than an optical illusion. It is a reflection of human nature, a window into the mind's penchant for order, familiarity, and connection. It explains why natural formations like the Martian Cydonia mesa, the Old Man of the Mountain, or even the mundane arrangement of a kitchen countertop can evoke the unmistakable impression of a human face. To see a face in a rock is, ultimately, to see ourselves, our need for connection, our love of story, and the remarkable power of the human imagination to breathe life into the inanimate, to find the familiar in the unfamiliar, and to discover wonder in the random patterns of the universe. The study of this phenomenon continues to expand, encompassing neuroscience, psychology, anthropology, and even artificial intelligence. Scientists are learning more about how facial recognition networks develop in the brain, how they interact with emotion and social cognition, and how culture and experience modulate perception. As we continue to explore Mars, the Moon, distant asteroids, and exoplanets, pareidolia will undoubtedly continue to shape our interpretations. The images we see will always be filtered through the lens of human cognition, influenced by evolutionary history, psychological wiring, and the endless capacity of the mind to detect faces, patterns, and meaning in the vast, mysterious cosmos. From the moment humanity first raised its eyes toward the stars, there has been an unending fascination with the mysteries that lie beyond our own world. The planets, moons, and countless distant points of light in the sky have always held a magnetic pull on the human imagination, inspiring wonder, curiosity, and sometimes even fear. Among these celestial bodies, Mars, the red planet, has always stood out as a particular focus of public attention. Its striking reddish hue, visible even to the naked eye on clear nights, has made it a constant presence in human observation for thousands of years. Over time, this distant world has become the center of countless theories, speculations, and stories, ranging from purely scientific curiosity to elaborate tales of conspiracy and hidden truths. The fascination with Mars is not merely a modern phenomenon, it stretches back centuries, but the advent of space exploration, telescopic advances, and digital imaging in the 20th century brought the planet into unprecedented detail, fueling imaginations and intensifying public interest. One of the most striking moments in the history of human observation of Mars came in the late 19th and early 20th centuries, when astronomers with powerful telescopes began to report what they interpreted as features resembling canals on the Martian surface. Italian astronomer Giovanni Schiaparelli, in the year 1877, described observing long straight lines across the planet, which he called canali. The term in Italian simply meant channels, but in translation it became canals, implying artificial construction. This linguistic twist sparked a wave of public fascination and speculation, most notably inspiring American astronomer Percival Lowell, who in the year 1895 devoted his life to studying these Martian canals and proposed that they were evidence of an advanced civilization attempting to survive on a dying planet. Lowell's theories, though later proven incorrect by more advanced imaging and scientific analysis, captured the public imagination. Newspapers, popular magazines, and even works of fiction carried stories of intelligent Martians, emphasizing the allure of the unknown and the human tendency to project our own experiences and desires onto distant worlds. The canals became a symbol, not just of Mars itself, but of the possibilities that lay beyond Earth, a tantalizing hint that we might not be alone in the universe. As the 20th century progressed and technology improved, humanity's capacity to study Mars increased dramatically, and with it, the complexity of both fascination and speculation. The year 1965 marked a significant turning point when NASA's Mariner 4 spacecraft conducted the first successful flyby of Mars, sending back a series of black and white photographs that revealed a barren, cratered landscape. For many, this was a sobering moment. The canals, the supposed signs of intelligent life, were nowhere to be seen. Yet even in the face of these new images, the public fascination did not diminish. It transformed. With each new mission, Mariner 6 and 7 in 1969, Viking 1 and 2 in 1976, and later missions such as Mars Global Surveyor in 1997, the details of Mars's surface became clearer, yet the planet continued to spark the imagination. The more scientists explained, measured, and analysed, the more enthusiasts, writers, and theorists speculated. This duality, scientific revelation paired with imaginative projection, helped fuel the creation and persistence of conspiracy theories. Among the most famous sparks for speculation in the modern era was the appearance of the so-called face on Mars in the Cydonia region. In 1976, the Viking 1 orbiter captured an image of a mesa in the northern hemisphere of Mars that appeared, to some observers, to resemble a human face. The photograph, grainy and taken under particular lighting conditions, immediately ignited a wave of public interest. Popular media, science fiction writers, and conspiracy theorists all embraced the idea that this formation might not be a natural structure, but rather a relic of a long-lost Martian civilization. Books and television programs proliferated, each exploring the possibility that intelligent beings once inhabited Mars, leaving behind monuments, pyramids, and even complex cities. Theories ranged from the plausible-sounding to the fantastical. Some suggested that an ancient Martian race built vast structures similar to those on Earth, while others imagined secret interactions with humanity across time. Despite repeated scientific studies demonstrating that the so-called face was a natural mesa, shaped by erosion, shadows, and perspective, the image had already cemented itself in public consciousness. It became a touchstone for discussions about life beyond Earth and the human desire to find meaning in seemingly random patterns. This fascination with Mars, Cydonia, and other planetary features is closely intertwined with broader patterns in human psychology and culture. Humans have an innate tendency to seek patterns, faces, and recognizable forms even where none exist, a phenomenon known as pareidolia. This tendency, combined with a desire to believe in larger narratives, of discovery, of hidden knowledge, of life beyond Earth, creates fertile ground for speculation and conspiracy. The face in Cydonia is only one of many examples. People have reported seeing pyramids, humanoid shapes, and other structures on Mars, the Moon, and even distant planets or moons within our solar system. While scientists are quick to explain these phenomena in terms of geology, lighting, and human perception, the public often embraces alternative explanations that hint at hidden truths or cover-ups. These beliefs are rarely random. They connect to broader cultural ideas about secrecy, advanced civilizations, and humanity's place in the cosmos. Conspiracy theories themselves are a particularly intriguing aspect of public fascination. They often emerge when there is a gap between official explanations and public curiosity, or when official information is incomplete, delayed, or difficult for non-experts to interpret. The history of Mars exploration provides numerous examples of this. For instance, some conspiracy theorists claim that NASA and other space agencies are deliberately hiding evidence of life on Mars, pointing to anomalies in images, delays in data release, or scientific uncertainty as evidence of cover-ups. Others argue that entire cities or remnants of ancient civilizations lie hidden on the Martian surface, deliberately obscured by technological means or by selective publication of images. These theories often incorporate elements of secrecy, government manipulation, and hidden agendas, tapping into a broader cultural fascination with the idea that there is more to the universe than mainstream science allows us to see. The rise of digital technology and the internet has further amplified this fascination and the spread of conspiracy theories. In the early 21st century, images from spacecraft such as the Mars Reconnaissance Orbiter, which launched in 2005, provided extremely high-resolution images of the Martian surface, revealing intricate details of rocks, craters, and dust formations. Enthusiasts could download these images, zoom in on formations, and share their interpretations online. Social media platforms, forums, and video sharing sites became hubs for speculation, allowing theories to spread more quickly and widely than ever before. Some communities focus on careful analysis, comparing images and measurements, while others embrace imaginative and sensational interpretations, weaving elaborate narratives about lost Martian civilizations, extraterrestrial contact, or hidden technologies. The participatory nature of the internet allowed anyone with curiosity and determination to become part of these discussions, blurring the line between scientific observation and creative storytelling. Another fascinating aspect of public interest is how it interacts with science fiction and popular culture. Mars has long been a favourite setting for novels, films, television shows, and video games, often featuring advanced civilizations, alien artifacts, or human colonization. Works such as Edgar Rice Burroughs' Barsoom series in the early 20th century, Ray Bradbury's The Martian Chronicles in 1950, and countless later novels and films have shaped how people imagine the planet. These fictional narratives feed into public fascination and can reinforce beliefs in hidden or mysterious aspects of Mars, especially when they echo real scientific discoveries or anomalies. The interplay between science, imagination, and speculation is a powerful engine that keeps public interest alive, even when scientific evidence contradicts fantastical ideas. Psychologically, this fascination can be seen as part of a larger human impulse to explore, discover, and find meaning. The universe is vast and largely unknown. Human minds are wired to seek patterns, connections, and explanations. When faced with ambiguous information, such as a blurry photograph of a Martian mesa or unusual geological formations, people naturally seek stories that make sense of it. Some will turn to scientific explanations, others to imaginative narratives, and some to conspiracy theories that suggest hidden truths. Each approach satisfies different aspects of curiosity. Science explains mechanisms, fiction inspires wonder, and conspiracy theories provide a sense of secret knowledge and involvement in uncovering hidden realities. The persistence of fascination with Mars and conspiracy theories is also linked to broader social and cultural trends. During periods of rapid technological change, political uncertainty, or social upheaval, people are more likely to engage with speculative ideas and question official narratives. The exploration of Mars, with its inherent mysteries and slow accumulation of data, creates a perfect stage for these dynamics. Each new image, each new piece of information, becomes a canvas onto which people project hopes, fears, and imaginations. The fact that scientific explanations evolve over time, as new data refines understanding, further fuels the sense of mystery. What was once considered a simple geological formation can later reveal unexpected complexity, leaving room for alternative interpretations and speculation. Throughout history, public fascination with Mars has demonstrated remarkable resilience. From Schiaparelli's canals in 1877 to the Viking images of 1976, from the Mars Global Surveyor in 1997 to the Mars Reconnaissance Orbiter in 2005, the planet has consistently inspired interest that transcends pure science. This fascination is multifaceted. It involves curiosity about other worlds, hope for discovering life, engagement with imaginative narratives, and even the thrill of conspiracy and hidden knowledge. It is a reflection of humanity's desire to understand the cosmos, assert our place within it, and imagine what might exist beyond the boundaries of our own experience. Even today, in the early 21st century, the fascination continues unabated. As robotic explorers like the Curiosity rover, which landed on August 6, 2012, and Perseverance rover, which landed on February 18, 2021, send back detailed images, chemical analyses, and geological measurements, the public eagerly follows every update. Enthusiasts, writers, and theorists scrutinize every photograph, every rock formation, every anomalous shadow, seeking signs of life or intelligence. Theories continue to proliferate, some grounded in scientific curiosity, others in imaginative speculation or outright conspiracy. Mars remains, in many ways, a mirror for human curiosity, creativity, and the enduring drive to find meaning in the vast, unknown universe. Ultimately, The public fascination with Mars and the accompanying conspiracy theories illustrates something profound about human nature. We are explorers by instinct, storytellers by necessity, and pattern seekers by design. The planet Mars, with its striking red deserts, towering volcanoes, and enigmatic mesas, provides a perfect canvas for these impulses. While science works methodically to uncover the truths of geology, atmosphere, and potential habitability, the human imagination simultaneously weaves stories, posits civilizations, and speculates on secrets hidden just beyond the reach of our current understanding. Conspiracy theories are part of this broader landscape of fascination, reflecting both skepticism and creativity, doubt and hope. They are not simply obstacles to understanding. They are expressions of our desire to engage with the unknown, to find significance, and to imagine worlds beyond our own. In conclusion, the public fascination with Mars and the proliferation of conspiracy theories surrounding it are the result of a complex interplay of history, psychology, culture, and science. From early telescopic observations to modern robotic explorers, from the misinterpretation of natural formations to the creation of imaginative narratives, humanity's engagement with Mars has been rich, multifaceted, and enduring. The stories, theories, and speculations surrounding the red planet reveal as much about human curiosity and creativity as they do about Mars itself. They illustrate our deep desire to understand the cosmos, to uncover hidden truths, and to imagine possibilities that stretch far beyond the limitations of our own planet. Mars, in all its mystery and allure, remains a symbol of exploration, imagination, and the unending quest to find our place in the universe, inspiring generations to look up at the night sky and wonder what secrets lie among the stars. Even as scientific missions continue to explore Mars in ever greater detail, and as our knowledge of the planet grows, the fascination and speculation will not fade. Human imagination thrives in spaces of uncertainty and discovery, and Mars provides the ultimate stage, a distant, barren, yet endlessly intriguing world that invites questions, stories, and dreams. Conspiracy theories, far from being mere distractions, are part of the tapestry of human engagement with the unknown, reflecting our innate desire to connect, to question, and to imagine what might lie hidden just beyond the boundaries of perception. For decades, Cydonia has been under intense scrutiny, from the first blurry photographs taken by orbiting spacecraft in the mid-1970s to the high-resolution images captured by more advanced instruments in the early 21st century. Despite the tremendous progress in Martian exploration, the possibility that Cydonia might still hold hidden secrets beneath its surface continues to spark curiosity and speculation. Could there, buried under layers of Martian soil and rock, lie remnants of structures or artifacts that have yet to be discovered? Could the ground itself be concealing evidence of processes, natural or otherwise, that challenge our understanding of the red planet? The idea that there could be something hidden beneath Cydonia's surface is not purely a product of fanciful imagination. Geologically, Mars is a dynamic world, subject to processes that can bury, preserve, or alter features over millions of years. Wind erosion, dust storms, volcanic activity, and the slow creep of ice have shaped the Martian landscape, sometimes revealing dramatic formations, and sometimes covering them so completely that they remain invisible to even the most sophisticated cameras. On Earth, it is well known that ancient cities, monuments, and tombs can lie concealed under layers of soil, sand, or volcanic ash for thousands of years before they are discovered. Why then should Mars be considered immune to the possibility that its own surface might hide secrets? Cydonia is characterized by a mixture of mesas, buttes, and pyramidal hills, formations that capture the imagination because of their apparent symmetry and geometric forms. The most famous of these, the so-called Face on Mars, drew worldwide attention when photographs from the Mariner 9 spacecraft were first transmitted back in the 1970s. At the time, the resolution of the images was limited, and shadows cast by the Martian sun accentuated certain features, creating the illusion of a face. Later, more detailed images taken by the Mars Global Surveyor in the late 1990s revealed that the face was a natural formation of rock and dust, with erosion patterns that created the impression of eyes, a nose, and a mouth. Yet, the fascination did not end there. even if the face itself is a product of natural processes, the question of what lies beneath it remains open. Just as a statue on Earth might be partially buried by centuries of soil accumulation, the formations in Cydonia could conceal structures, cavities, or layers that remain hidden from view. Recent advances in orbital imaging and remote sensing have dramatically increased our ability to investigate Mars. Instruments capable of penetrating the surface with radar waves, such as the shallow radar aboard the Mars Reconnaissance Orbiter, can reveal subsurface features in surprising detail. These technologies have already detected ice deposits beneath the Martian surface, underground channels, and areas that may have once held liquid water. In Cydonia, these techniques offer the tantalizing possibility of discovering voids, unusual rock arrangements, or even materials that do not match the surrounding geology. If such anomalies were detected, they could provide clues to past geological processes, or more speculatively, to events that might have involved intelligent activity, though there is no concrete evidence to suggest this. The notion of hidden secrets underground in Cydonia is further supported by the planet's history of climate change. Mars is known to have undergone dramatic shifts in its atmosphere and climate over the past billions of years. There is strong evidence that the planet once had liquid water on its surface, with rivers, lakes, and possibly shallow seas. The presence of water, even in small amounts, could have contributed to the preservation of unusual formations, buried sediments, or other features of interest. Just as ancient ruins on Earth are often found near old riverbeds, or in regions where soil accumulation has preserved structures, similar conditions on Mars could mean that Cydonia contains areas where the surface has protected whatever lies beneath from erosion and extreme weather. Another factor that fuels speculation about subterranean secrets is the pattern of the Cydonia region itself. Some formations in this area display angular, linear, or geometric patterns that are unusual compared to surrounding terrain. While these patterns can often be explained by natural geological processes such as wind erosion, volcanic activity, or sediment deposition, the regularity of some arrangements invites curiosity. Could there be hidden layers of rock or sediment that are more uniform, more structured, or more different from the visible surface than current images suggest? The possibility, however slim, keeps the imagination active, encouraging scientists to continue probing with more advanced instruments, simulations, and analysis techniques. It is important to remember that the search for hidden features beneath Cydonia is not limited to the realm of speculation. Robotic exploration, while focused primarily on other regions of Mars such as Gale Crater and Jezero Crater, has demonstrated that ground-based analysis can uncover secrets invisible from orbit. Mars rovers, equipped with drilling tools, spectrometers, and ground-penetrating instruments, have revealed the composition of Martian soil, the presence of minerals formed in water, and even the existence of ancient microbial environments. While no rover has yet visited Cydonia, the technological capability exists to send a mission specifically designed to investigate its subsurface. Such a mission could combine orbital radar surveys with lander-based drills, or even autonomous tunneling devices to reveal layers hidden from view for millions of years. The human fascination with hidden spaces and unknown structures extends beyond scientific inquiry into the psychological and cultural realm. The face on Mars became a cultural icon precisely because it tapped into a deep human tendency to recognize patterns, especially faces, even where none exist. This tendency, known as pareidolia, is part of the reason why the public continues to wonder if Mars hides more than meets the eye. If there are features beneath the surface of Cydonia that do not conform to ordinary geological expectations, they will capture the imagination of humanity in ways that can influence public interest, funding, and the direction of future exploration. Every generation of Martian exploration builds upon the curiosity of the previous one, and the possibility of underground secrets keeps this curiosity alive. Scientific caution is necessary, however. The history of Cydonia is filled with examples of early excitement, followed by careful re-evaluation. Initial photographs suggested faces and pyramids. Later high-resolution imagery revealed natural formations. The lesson is clear. The Martian environment can produce astonishingly suggestive forms, and human perception is eager to interpret these forms as something more than they are. Nonetheless, this does not rule out the possibility that further exploration could uncover genuine anomalies, even if they are purely geological. underground cavities, layered sediments, or mineral deposits could all constitute significant discoveries that enhance our understanding of Mars without requiring the presence of intelligent activity. Beyond the purely geological, the search for hidden features beneath Cydonia could also have implications for astrobiology. If life ever existed on Mars, whether microbial or otherwise, the subsurface would have been a more hospitable environment than the harsh surface. Buried ice, sediment layers, and sheltered cavities could have provided protection from radiation, extreme temperatures, and dust storms. Consequently, Cydonia's hidden layers, if accessible, might contain preserved chemical signatures, organic compounds, or even microbial fossils that would revolutionize our understanding of life beyond Earth. The exploration of Cydonia, therefore, is not just a matter of curiosity about formations that look like faces or pyramids. It is a quest to probe a region where the history of Mars, and perhaps the history of life itself, may be recorded in ways that are still hidden. Technological innovation will play a central role in uncovering what lies beneath Cydonia. Future missions could employ increasingly sophisticated ground-penetrating radar capable of distinguishing between different types of rock and sediment, detecting voids or cavities, and mapping underground layers with remarkable precision. Instruments that analyze thermal properties, magnetic fields, or chemical composition could reveal areas of unusual interest. Autonomous robotic explorers, equipped with drills, sensors, and even small excavation tools, could investigate these anomalies in situ, providing direct evidence of subsurface conditions. Such missions might also incorporate artificial intelligence systems capable of recognizing patterns or deviations in the data that human analysts might overlook, increasing the likelihood of discovering hidden features. The challenges of such exploration are formidable. Mars is a harsh environment, and Cydonia itself presents logistical difficulties. The terrain is rugged, with mesas, valleys, and steep cliffs that would require carefully engineered landing and mobility systems. Communication delays between Earth and Mars make real-time control impossible, requiring autonomous operation. Additionally, interpreting subsurface data is inherently complex, as radar and other instruments can produce signals that are ambiguous or influenced by multiple factors. Yet, each challenge presents an opportunity for innovation, pushing engineers and scientists to develop new techniques that could be applied not only to Mars, but to other planetary bodies across the solar system. Public interest in Cydonia continues to be a driving force behind the idea that secrets might be hidden underground. Popular culture, documentaries, books, and online discussions keep the fascination alive, often blurring the line between science and speculation. While sensationalist claims about Martian civilizations capture headlines, serious scientific inquiry benefits from the same curiosity. Funding agencies and space programs respond to public enthusiasm, which means that the ongoing interest in Cydonia can indirectly support missions designed to explore the Martian subsurface. The interplay between imagination and rigorous investigation is a hallmark of planetary science, as history has shown from the exploration of the Moon, Venus, and Mars itself. In imagining what could lie beneath Cydonia, one must balance caution with wonder. The most likely scenario is that the subsurface is shaped by geological processes, layers of rock, ice, and sediment that tell a story of Mars's history over billions of years. Yet, the human mind cannot help but imagine the extraordinary. Chambers carved by unknown processes, mineral formations unlike any seen before, or even traces of water activity that might have concentrated in hidden pockets. Every discovery, no matter how small, adds a piece to the puzzle of Martian history. Just as early archaeologists on Earth uncovered civilizations buried for thousands of years, the Martian surface and its subsurface layers may contain stories waiting to be told, preserved in silence beneath the red dust. The passage of time is another factor that enhances the mystery. Cydonia has endured millions, perhaps billions, of years of cosmic and environmental forces. Meteorite impacts, dust storms, and climate variations have all interacted with its surface, potentially burying or altering features that might once have been visible. This passage of time means that the present surface of Cydonia could be only a thin veil over a complex and hidden history. Exploring beneath this surface is akin to reading the pages of a book written in layers, each stratum representing an epoch in Mars's geological and environmental evolution. Cydonia, that enigmatic region on the northern hemisphere of Mars has long captivated the curiosity of scientists, space enthusiasts, and the general public alike. Its distinctive landforms, most famously the so-called face on Mars and surrounding pyramid-like structures, have provoked debates, discussions, and endless speculation since they were first captured by orbiting spacecraft. While early images taken by the Viking orbiter in the mid-1970s sparked fascination with the possibility of ancient Martian civilizations, subsequent missions provided ever clearer views that suggested natural geological explanations. Yet, the allure of Cydonia has never diminished, and it remains one of the most intriguing regions on the Martian surface, precisely because it sits at the intersection of science, mystery, and imagination. To fully understand Cydonia, future missions specifically designed to revisit this region are essential, not only to settle lingering questions about the nature of its formations, but also to advance our broader understanding of Mars, its history, and its potential to host life. The concept of sending missions specifically to Cydonia represents a significant shift from general Mars exploration, which typically focuses on landing sites believed to hold scientific promise for understanding past habitability, water history, or atmospheric evolution. While the majority of Mars rovers and orbiters have prioritized areas such as Gale Crater, Jezero Crater, and the polar regions due to their abundant signs of past water activity or mineral diversity, Cydonia presents a different kind of scientific opportunity. Its appeal lies not only in the unusual shapes and apparent geometrical patterns, but also in the complex interplay of erosion, wind activity, and geological processes that could have produced such formations. Future missions focused on this region would need to combine advanced imaging technology, precise topographical mapping, and potentially even in situ exploration to resolve the questions that have persisted for nearly half a century. One of the most important roles of future missions to Cydonia will be to provide ultra-high-resolution imaging that surpasses anything previously achieved. The Viking orbiter images from the mid-1970s, though groundbreaking at the time, were limited by the technology available and by the constraints of orbital photography from several hundred kilometers above the Martian surface. These early images captured shapes that appeared remarkably human-like, triggering interpretations and excitement that quickly captured public imagination. Later missions, such as Mars Global Surveyor in the late 1990s, provided sharper views, revealing that the features in Cydonia were subject to natural processes like wind erosion and sediment deposition. Even so, the debate has never fully disappeared, because the images, while detailed, still lacked the precision and multiple perspectives needed to conclusively determine the nature of every formation. Future missions could rectify this by employing next-generation imaging systems capable of capturing centimetre-level detail from orbit, allowing scientists to examine subtle textures, angles, and shadowing that could differentiate natural rock formations from anything that might conceivably be artificial. Such detailed imaging would also help model the geological history of the region with unprecedented clarity, showing exactly how wind, ice, and dust have interacted over millions or even billions of years to sculpt the landscape we see today. Beyond orbit, sending landers or rovers specifically to Cydonia would represent a monumental step forward. While rovers such as Spirit, Opportunity, Curiosity, and Perseverance have explored regions selected for their scientifically interesting geology, a mission designed with Cydonia as its primary target would need to focus on both imaging and detailed analysis of surface materials. This could involve mobile platforms equipped with advanced spectrometers, drills capable of extracting subsurface samples, and high-definition panoramic cameras that can reconstruct the terrain in 3 dimensions. By examining the composition of rocks, soils, and dust in and around formations like the face on Mars and the nearby pyramidal hills, scientists could determine whether the shapes are simply the result of erosion and tectonic processes, or if there are anomalies that demand further explanation. Moreover, direct sampling could provide isotopic and mineralogical data that reveal the chronological sequence of geological events in the region, potentially dating the formations and linking them to broader Martian history. Another key role of future Cydonia missions would be the deployment of aerial exploration systems. Drones, balloons, or even small rotorcraft similar to the Ingenuity helicopter currently operational near the Perseverance rover could provide low-altitude perspectives unavailable from orbiters. Such systems could fly close to rock formations, capture images from multiple angles, and map features that are difficult to access from ground level. By combining aerial imagery with surface data and orbital photographs, scientists could generate comprehensive three-dimensional models that leave no detail unexamined. These models would allow researchers to analyze angles, symmetries, and alignments in the landscape with remarkable precision, offering definitive evidence to settle long-standing debates about the so-called artificiality of certain structures. This multi-layered approach, combining orbit, aerial observation, and surface exploration, would represent the most thorough examination of Cydonia ever attempted. In addition to imaging and geological analysis, future missions could play a critical role in studying the environmental context of Cydonia. Understanding the regional climate, wind patterns, dust accumulation, and seasonal changes in temperature and humidity is essential for reconstructing the processes that shape the landscape. For example, Martian winds are capable of moving vast quantities of dust and sand over millennia, slowly sculpting rocks into shapes that might appear geometric or symmetrical. Ice deposition and sublimation could also contribute to unusual formations, while periodic dust storms can erode and smooth surfaces in unpredictable ways. By monitoring these processes in real time with meteorological instruments, missions could directly observe the natural forces that have shaped Cydonia, confirming or refuting hypotheses about erosion, deposition, and sedimentary layering. Long-term environmental monitoring would not only clarify the origin of the region's formations, but also inform models of Martian climate evolution more broadly. The potential for subsurface exploration adds another compelling dimension to Cydonia-focused missions. While surface features tell part of the story, much of Mars's geological history lies hidden beneath layers of dust, rock, and sediment. Ground-penetrating radar, drills, or even seismic sensors could reveal buried structures, sedimentary layers, or subsurface anomalies that are invisible from above. Discovering variations in density, composition, or layering could help explain the formation of the region's most puzzling features. For instance, if the so-called face sits atop a resistant rock layer or an unusual formation of sedimentary deposits, this would provide strong evidence for a natural geological origin. Conversely, any unexpected patterns beneath the surface would demand careful scientific attention, potentially inspiring new lines of inquiry into the region's history. By integrating surface and subsurface data, future missions could create a complete, multi-dimensional understanding of Cydonia, leaving little room for ambiguity. Another important consideration for future missions is the potential for international collaboration. Cydonia's allure has captured imaginations worldwide, and future expeditions could benefit from the expertise and technological contributions of multiple space agencies. Collaborative missions could bring together orbital satellites from one country, surface rovers from another, and aerial drones or instruments from yet another, creating a synergistic network of observation and analysis. Such collaboration would not only enhance scientific output, but also reduce costs and risks, allowing for more ambitious experiments and extended mission durations. In addition, international participation could foster greater transparency and public engagement, countering the speculation and conspiracy theories that have historically surrounded Cydonia by making the mission's methods, data, and results openly available to researchers and enthusiasts everywhere. The role of future missions in testing hypotheses about potential artificiality cannot be understated. While mainstream science overwhelmingly supports natural explanations, there remains a persistent interest in investigating the region for any evidence of intelligent influence. Future missions, equipped with precise imaging, advanced sensors, and sophisticated analytical tools, could systematically evaluate claims about geometrical precision, alignment with astronomical features, or unusual material compositions. By applying rigorous scientific methods, researchers could definitively confirm the natural origins of the formations or, if anomalies are found, direct attention to unexplained phenomena in a disciplined, methodical way. This scientific approach would satisfy both the curiosity of the public and the standards of professional inquiry, providing a clear record of investigation that can withstand scrutiny and debate. Future missions could also incorporate cutting-edge technologies that were not available during earlier exploration efforts. Advances in artificial intelligence, machine learning, and autonomous navigation could allow rovers and drones to analyze data in real time, prioritizing areas of interest and adjusting exploration plans dynamically. For example, a rover could detect unusual rock textures or formations and automatically focus imaging and sampling efforts on those areas, ensuring that no detail is overlooked. Similarly, AI algorithms could process vast quantities of orbital and surface data to detect patterns invisible to human eyes, revealing subtle geological processes or formations that might otherwise be missed. By leveraging these technologies, missions targeting Cydonia could achieve levels of efficiency and precision unimaginable during the Viking era or even the early 21st century. The educational and cultural impact of future Cydonia missions would be substantial as well. Cydonia has captured public imagination for decades, inspiring books, documentaries, films, and countless discussions about the possibility of life beyond Earth. By designing missions that specifically revisit this iconic region, space agencies can reignite public interest in planetary science, astronomy, and space exploration more broadly. Detailed images, three-dimensional models, and live data streams could be shared widely, allowing students, researchers, and enthusiasts to explore the Martian landscape virtually. Such engagement would foster a deeper appreciation for the scientific method, the challenges of space exploration, and the wonder of distant worlds. In this way, missions to Cydonia would serve not only as scientific investigations, but also as powerful tools for education, inspiration, and global connection. Moreover, revisiting Cydonia could provide insights into planetary processes that extend beyond Mars itself. Understanding how wind, ice, and sediment interact to produce unusual landforms can inform our knowledge of geological phenomena across the solar system, from Mercury to the icy moons of Jupiter and Saturn. By studying how natural forces create apparent patterns and symmetries, scientists can refine models of landscape evolution, erosion, and sediment transport, applying these lessons to other planets and moons. In essence, Cydonia serves as both a laboratory and a case study for understanding the complex interplay of natural forces that shape planetary surfaces, offering insights that extend far beyond Mars. The planning of future missions must also account for the inherent risks and challenges of exploring Cydonia. The region is characterized by rough terrain, rocky outcrops, and potential dust hazards, making lander or rover navigation challenging. Successful exploration will require robust engineering, precise navigation systems, and contingency planning to ensure that instruments can safely traverse the landscape and collect meaningful data. By overcoming these challenges, missions can not only achieve their objectives, but also advance technologies and methodologies that will benefit future planetary exploration across the solar system. Each success at Cydonia contributes to the broader toolkit of interplanetary science, improving our ability to explore, understand, and interpret alien worlds. The role of future missions specifically targeting Cydonia cannot be overstated. These missions would provide unprecedented clarity on the nature of the region's formations, settling debates that have persisted for nearly 50 years, while expanding our understanding of Martian geology, climate, and environmental history. By combining high-resolution orbital imaging, surface exploration, aerial surveys, subsurface analysis, and advanced technology, these missions could definitively determine whether the enigmatic shapes of Cydonia are the result of natural processes or something more extraordinary. They would also serve as instruments of education, inspiration, and international collaboration, engaging the public and scientific communities alike. Beyond Mars, the lessons learned from Cydonia would inform our understanding of planetary processes throughout the solar system, demonstrating the profound value of returning to one of the most intriguing and mysterious regions on our neighbouring planet. With careful planning, innovative technology, and rigorous scientific methodology, the next generation of missions to Cydonia promises not only to resolve old questions, but also to open entirely new chapters in the story of Mars exploration, ensuring that the region continues to captivate, challenge, and inspire humanity for decades to come.